committee. Let's take the moment of silence to pray to Almighty Allah Subhanahu wa Ta'ala. So our event, our online event today, and all the live streaming, all the technical duties that we have to complete today, get the blessing from the
Recording in
Almighty Allah.
progress.
Get the blessing from the Almighty God. Moment of silence start. Moment of silence finished. All program officers, stand by, IT ready. Pak Agus, please play the video.
Indonesia is a beautiful archipelago country with a tropical climate and an enormous natural resource. Forests and their biodiversity are the most valuable natural resources and the natural capital of Indonesia. The forest area in Indonesia continues to shrink. The accelerated population growth has caused forest exploitation in fulfilling the demand for wood raw materials, both legally and illegally. While this demand keeps increasing, the wood supply continues to decline. Wood is a raw material that is greatly useful and valuable for humanity. It is used for construction materials, furniture, handicrafts, firewood, and a variety of household uses. Founded in 2002, the Research Center for Biomaterials, Indonesian Institute of Sciences, has been conducting research in natural materials, such as wood and natural fibers. The center also focuses on developing processes, technology, and design to produce value-added products. The Modification and Engineering of Biomaterials Research Group focuses on characterizing and modifying lesser-value wood materials into more valuable products. This research group works closely with another research group called Biocomposites Engineering and EcoStructure. They've been working on engineering wood-based materials and natural fibers, such as bamboo, into functional composite materials. This research group also works on building material design and providing a technology package of an eco-friendly home, known as EcoHouse. All parts of the EcoHouse use eco-friendly composite materials. It also utilizes an architectural concept that conserves electrical energy. One of the research interests of the Biomass Process Technology and Bioremediation Research Group involves the utilization of lignocellulosic materials, such as non-wood natural fiber, and incorporating their conversion process to create bioenergy or bioethanol. Lignocellulosic materials can also be used as a medium for making enzymes that are used in bioremediation processes. These waste-degrading enzymes can be used to remove color and toxic materials present in textile waste. This research group is also developing derivative products such as wood adhesives made from natural latex. These adhesives do not produce emissions of harmful substances. They are friendly to human health and the environment. The Urban Agricultural Pest Management Research Group has focused their research on maintaining the quality of the wood commodity and protecting cellulose-based products from the attack of pests such as insects and fungi. By utilizing natural materials such as plant extracts and microorganisms, this research group has been developing eco-friendly urban and agricultural bioinsecticides and studying their biocontrol approaches through laboratory bioassays as well as behavioral and ecological studies. The research outcome is part of this group's efforts to tackle the process of biodeterioration that is caused either by wood-attacking insects or wood rot fungi. Through a series of chemical, biological, mechanical, and physical processes, natural materials can be transformed into biopolymers, bioactive compounds, conventional composite materials, advanced and ingenious materials, as well as other products that are eco-friendly. In addition to providing high economic value products, natural-based materials can also be converted into renewable fuels as substitutes for fossil fuels. Appointed as the Center of Excellence for Lignocellulose, the Research Center for Biomaterial also has an ISO IEC 9001-2008 certification for quality management systems. It also serves as an appointed urban agricultural pest testing laboratory authorized by the Pesticide Commission of the Indonesia Ministry of Agriculture. Since 1996, the Research Center for Biomaterials has been a satellite office for foreign cooperation between LIPI with Kyoto University, Japan. The center is also active in research programs in Asia, such as JSPS and SATREPS. In addition, the Research Center for Biomaterials has been cooperating with various research institutions, universities, and industry from home and abroad. The Research Center for Biomaterials continues to develop advanced materials and bioproducts through a series of processes in order to support a clean and healthy environment. The Research Center for Biomaterials, Indonesian Institute of Sciences, appointed as a center of excellence, continuously advances innovation in addressing global challenges.
Okay, so ladies and gentlemen, good morning, local time in Indonesia, and welcome to everyone. For those of you who are already joined with us in the Zoom meeting, I can see now we have around 131 participants. So I would like to just announce that we are about to begin our event today. And we will start at 10 a.m. local time in Indonesia. So in the meantime, we will wait for everyone to join with us, both in the Zoom meeting or through the live streaming in the LIPI YouTube channel. So maybe one reminder is that you can also rename your Zoom meetings name with for the presenters and participants, and you can see the guidance in the chat room right now. So we will wait for everyone to join with us. So you still have some time to prepare yourself, and thank you very much for your attention.
Indonesia is a beautiful archipelago country with a tropical climate and an enormous natural resource. Forests and their biodiversity are the most valuable natural resources and the natural capital of Indonesia. The forest area in Indonesia continues to shrink. The accelerated population growth has caused forest exploitation in fulfilling the demand for wood raw materials, both legally and illegally. While this demand keeps increasing, the wood supply continues to decline. Wood is a raw material that is greatly useful and valuable for humanity. It is used for construction materials, furniture, handicrafts, firewood, and a variety of household uses. Founded in 2002, the Research Center for Biomaterials, Indonesian Institute of Sciences, has been conducting research in natural materials, such as wood and natural fibers. The center also focuses on developing processes, technology, and design to produce value-added products. The Modification and Engineering of Biomaterials Research Group focuses on characterizing and modifying lesser-value wood materials into more valuable products. This research group works closely with another research group called Biocomposites Engineering and EcoStructure. They've been working on engineering wood-based materials and natural fibers, such as bamboo, into functional composite materials. This research group also works on building material design and providing a technology package of an eco-friendly home, known as EcoHouse. All parts of the EcoHouse use eco-friendly composite materials. It also utilizes an architectural concept that conserves electrical energy. One of the research interests of the Biomass Process Technology and Bioremediation Research Group involves the utilization of lignocellulosic materials, such as non-wood natural fiber, and incorporating their conversion process to create bioenergy or bioethanol. Lignocellulosic materials can also be used as a medium for making enzymes that are used in bioremediation processes. These waste-degrading enzymes can be used to remove color and toxic materials present in textile waste. This research group is also developing derivative products such as wood adhesives made from natural latex. These adhesives do not produce emissions of harmful substances. They are friendly to human health and the environment. Urban Agricultural Pest Management Research Group has focused their research on maintaining the quality of the wood commodity and protecting cellulose-based products from the attack of pests such as insects and fungi. By utilizing natural materials such as plant extracts and microorganisms, this research group has been developing eco-friendly urban and agricultural bioinsecticides and studying their biocontrol approaches through laboratory bioassays as well as behavioral and ecological studies. The research outcome is part of this group's efforts to tackle the process of biodeterioration that is caused either by wood-attacking insects or wood rot fungi. Through a series of chemical, biological, mechanical, and physical processes, natural materials can be transformed into biopolymers, bioactive compounds, conventional composite materials, advanced and ingenious materials, as well as other products that are eco-friendly. In addition to providing high economic value products, natural-based materials can also be converted into renewable fuels as substitutes for fossil fuels. Appointed as the Center of Excellence for Lignocellulose, the Research Center for Biomaterial also has an ISO IEC 9001-2008 certification for quality management systems. It also serves as an appointed urban agricultural pest testing laboratory authorized by the Pesticide Commission of the Indonesia Ministry of Agriculture. Since 1996, the Research Center for Biomaterials has been a satellite office for foreign cooperation between LIPI with Kyoto University, Japan. The center is also active in research programs in Asia, such as JSPS and SATREPS. In addition, the Research Center for Biomaterials has been cooperating with various research institutions, universities, and industry from home and abroad. The Research Center for Biomaterials continues to develop advanced materials and bioproducts through a series of processes in order to support a clean and healthy environment. The Research Center for Biomaterials, Indonesian Institute of Sciences, appointed as a Center of Excellence, continuously advances innovation in addressing global challenges.
Okay, thank you for waiting. We also just watched the precious message from us, the committee, for everyone, for our honorable keynote speakers, invited speakers, all the presenters, participants who give us your big support for us and show the excitement to join this event. Right now it is still raining in Bogor City, so it is a very touching moment for all of us this morning. But anyway, we are very excited to continue today's event, and we hope that all of you are truly enjoy our event today. So, Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, good morning local time in Indonesia, and welcome to the first international conference of Lignocellulose in conjunction with the 10th International Symposium for Sustainable Humanosphere 2021. I'm Fanny Clara Ardiati, and it is a pleasure to be your host today. So today is the second and also the last day of our event of conference and symposium, which is organized by JSPS Alumni Association of Indonesia in collaboration with Research Center for Biomaterials, National Research and Innovation Agency, BRIN, Republic of Indonesia. We would like to address our big appreciation for all the stakeholders who give their big supports to this event from JSPS Bangkok Office, Thailand, LAPAN, BRIN Indonesia, RISH-Kyoto University, Japan. We would like to also thank our valuable partners for their supports from many national universities in Indonesia, from IPB University, Padjajaran University, Islamic University of Indonesia, and Trisakti University. We also would like to thank our valuable partners from even far away in Sumatera and Kalimantan, from Jambi University, Lambung, Mangkurat University, Mulamarwan University, and University of Sumatera Utara. But before we begin, I would like to invite and appreciate everyone if you can turn on your camera so that we can see all of us here today, maybe to see your colleagues and everyone here. So, but please kindly remain turned off your audio during this morning session. Thank you. First of all, let me give a very warm welcome to our honorable guests who are already joined with us and will join with us today. To Professor Yoshio Otani as the Director of JSPS Bangkok Office. To Professor Masato Shiotani from RISH-Kyoto University, Japan. Also to Professor Kenji Umemura from RISH-Kyoto University, Japan. Also to Professor Dr. Erna Sri Adiningsih as Acting Director of National Institute of Aeronautics and Space, National Research and Innovation Agency, BRIN. To Dr. Iman Hidayat as Acting Director of National Institute of Life Sciences, BRIN. To Dr. Akbar Hanif Dawam as the Head of Research Center for Biomaterials, BRIN. And to Dr. Didi Tarmadi as the Chairman of Icon-Lig and ISSH 2021. And not forget to also mention for our 13 honorable invited speakers who give us their supports by sharing their knowledge and giving us their lectures in this today's event. I would like to send my greetings for those our honorable invited speakers who are already joined with us today, to Dr. Wendy Harjupa from Center for Atmospheric Science and Technology, National Institute of Aeronautics and Space, BRIN. Also to Dr. Muhammad Haswan Husid from University Science Malaysia, and to Professor Dr. Wahyu Duyanto and Dr. Hoirul Himi from Research Center for Biomaterials, BRIN, who already joined with us today in this morning. And also welcome to all distinguished guests and participants. Thank you for joining us today. So in the annual event of ISSH, together with our first international conference of lignocellulose, now we bring up the topic of frontier innovation of lignocellulose and humanosphere sciences towards sustainable development goals and climate change mitigations. So for today's agenda, we will start by two presentations from our keynote speakers. And after that, we will proceed to the parallel sessions with all the invited speakers and presenters. To begin today's event, let me invite our first keynote speakers. So for Professor Masato Shiotani from Research Institute for Sustainable Humanosphere, Kyoto University, Japan, who will deliver the first presentation. So to Professor Masato Shiotani, please, time is yours.
Thank you very much. Just a moment, I should bring my presentation material. Can you see and hear my presentation?
Yes, Prof, it's very well.
Okay, so my name is Masato Shiotani, the director of the Research Institute for Sustainable Humanosphere, Kyoto University. Today, I'd like to talk a general story about the humanosphere sciences. And in the first part, I'd like to show some general idea and which we are now aiming at as a research institute. And in the latter part, I'd like to show one good example of the humanosphere sciences, I believe, which is kind of characterized as a diagnosis and remediation of the Earth. So what is the humanosphere sciences? So as I said, that it is characterized as the diagnosis and remediation of the Earth. So we define the humanosphere as the sphere that supports human activities, including human living environment and forest sphere, the atmosphere, and the space environment. So here, just a moment. This is a cover page of a brochure of our research institute, and it's said the RISH and the space environment and atmosphere and forest sphere and the living environment. This is also described in the left panel. So we are trying to investigate to present the future programs of the humanosphere and explore innovative technology that will contribute to establishing a sustainable society in harmony with the natural environment. Actually, our English name of our institute is Research Institute for Sustainable Humanosphere. So I think the sustainability is one very important keyword here in the RISH. So why do we need such a sciences, kind of interdisciplinary sciences? So we are now facing the several hazardous events threatening the existence of humankind. So now we're facing the global warming, and it is becoming tangible, and consequently, with the disasters are intensified. And also, long distance communication is providing us kind of infectious diseases in the world that's becoming highly prevalent. So these problems are, just a moment. Okay. So this picture in the right down should be movie, but it's not moving. I'm sorry about that. So these problems are very complex in nature, and therefore only deepening academic knowledge in a scientific area cannot answer these complicated problems. So we need to investigate our expert knowledge in various areas with an interdisciplinary view. Okay, here. So this is one example of the last very heavy rainfall in the southern island of Japan, Kyushu Island. And so we had very serious problems after this, during this event. So humanosphere science is a kind of a subset or related, very closely related to the sustainability science. And the Sustainability Development Goals, SDGs, a collection of 17 interrelated goals designed to be a blueprint to achieve a better and more sustainable future for us. And the SDGs was set to, just a moment, sorry about this one. So SDGs was set in 2015 by the United Nations General Assembly and intended to be achieved by the year 2030. They are included in the United Nations resolution called the 2030 Agenda for what is colloquially known as Agenda 2030. And so our research institute, RISH, can not all, but the wide range of this SDG goals. And so we should keep our mind to the output toward the public and also the political area as a scientific achievement. So in our institute, we set 5 missions. By integrating the research result, we pursue solutions to present the future progress concerning the Humanosphere. So mission 1 is environment diagnosis and regulation of circulatory function, and mission 2, advanced development of science and technology toward a solar energy society. Mission 3, sustainable space environment for humankind, and mission 4, development and utilization of wood-based sustainable materials in harmony with the human living environment. And mission 5 is closely related to the quality of the future Humanosphere. So I'm not going in detail about these mission items, but we set those missions to achieve our goal. Our research institute, RISH, is also characterized as the Joint Usage Research Center. So we need to tackle these interdisciplinary programs in a new academic area. We have to have a good research materials or research instrument. So here we have several very unique instrument or facilities to investigate the Humanosphere sciences. And also we have a database that is for open use for the public. And also we are doing a project type collaborative research for promotion of collaborative projects. And as a part of our RISH activities, we, in 2016, we initiated a new program named Humanosphere Azure Research Node, ARN, so which is trying to strengthen the hub function of international collaboration, collaborative research, and fostering innovation in Humanosphere science with the ultimate goal of delivering solution on a global scale. So this is focused in the Southeast Asian countries, and also so people living in South Asian countries, scientists in South Asian countries, and also we have an equatorial atmosphere radar in the Indonesia. So we are utilizing the facilities and the human relation for the further Humanosphere sciences. We have a promotion video, or we made a promotion video last year, but I don't have enough time to show during my presentation. So if you are interested in our activities in RISH, please visit here. This is our website, and you can easily find this video, and you can see or enjoy our promotion video. So in the following, I would like to show one historical example related to the Humanosphere sciences, I believe. So this is an event, or this is a case about the ozone depletion. Ozone is mostly located in the upper atmosphere. and that produced the Antarctic ozone hole. So atmospheric ozone had been exceptionally depleted in the stratosphere over the Antarctic during spring of Southern Hemisphere. This was first documented in 1985, almost 35 years ago. And scientists performed extensive measurement from ground-based sensors and satellite and aircraft. So very complementary and complicated way. So they're trying to describe this event very minutely, or in that sense that globally. So based on these observations, the theoreticians proposed mechanisms for the depletion. And they finally concluded it is due to the release of the man-made chlorofluorocarbons and other halocarbons. And so the scientists resolved the kind of this very important question. And most importantly,
Apa nih, besok? Direbus dulu nggak sih biasanya Pak? Kalau mau FTGR gitu?
And most importantly, this result is contributing to establish international kind of the structure, Montreal Protocol, that is an international treaty designed to protect the ozone layer by phasing out the production of ozone depleting substances. And the final line that the import that is taken from the recent scientific ozone assessment report, ozone depletion scientific ozone assessment report. And in the first important sentence, they said that the actions taken under the Montreal Protocol have led to decreases in the atmospheric abundance of controlled ozone depleting substances and the start of the recovery of ozone, stratospheric ozone. So this is a very important message. And you may not know detail about the ozone hole, and you are now living very healthy, not problem world. But this is kind of realized under this Montreal Protocol, I can say. So I will just introduce some history of the ozone hole discovery and some investigation, and also some achievement of such an investigation. So this is an observation that Hare Bay is located in the Antarctic, supported by British Antarctic Survey. And this is the time total ozone section. So this shows the total ozone time series during the October from the end of 1950s and the middle of 1980s. And up to middle of 1970s, the ozone amount is rather flat, not so changing. But after that, the ozone is quickly decreasing in the Antarctic area. And here, the author Farman showed the fluorocarbon amount. So the axis is shown that the increasing in the down bay, and so the fluorocarbon is increasing, and at the same time the ozone decreasing. So they pointed out the relation between the decrease of ozone and the fluorocarbon. And this is also confirmed in the satellite observations. So this is the monthly mean total ozone in October observed by total ozone mapping spectrometers. And they use the South Polar projections with the pole indicated by a cross and the 30 degrees south latitude by dashed circles. And so we see some also small area here over the South Pole or the Antarctic area. And here the number is 270 and 240, 210. And finally, in 1985, 180. So the ozone is rapidly decreasing during this season. So this is also confirmed with the kind of in situ observations using the ozone sonde. So the sun ozone instrument is here, and this is launched with use of the this big balloon. And by the way, this is an observation at the South Pole, supported by the United States of America. And usually we see the ozone amount is like this, so we can see some ozone layer here. But in 1992, October 11th, or in 1993, October 12th, we see almost nothing of ozone here in the height range of 15 to 20 kilometers. So this is the actually affected by this, the total ozone. I didn't say about the unit of total ozone, but the total ozone is a kind of accumulation or integrated amount of ozone. So the ozone is highly depleted in the ozone layer here, in this case in around 50 to 20 kilometers. So such a decreasing trend is continuing in the 1990s. And so such an ozone hole is deepening and deepening. And here there are actually 4 South Antarctic stations, South Pole, Hare Bay, and the Japanese station Showa. And so it's very critical and hazardous to human. And the mechanism of the ozone hole is very closely related to the polar stratospheric clouds. So I'm not going in detail about the mechanism, but on the polar stratospheric clouds, there happened the heterogeneous reaction in the surface of cloud droplet, and it is very important to release the chlorine compound originally from the chlorofluorocarbons. So here is a schematic diagram of the mechanism of ozone hole. And I'm not going in detail about this mechanism, but here you can see the chlorine compound. There are many chlorine-related compound, and this chlorine is originally from the chlorofluorocarbons. So chlorofluorocarbon itself is very stable atmospheric constituent, but if so, the sheer chlorofluorocarbons going up to the very high altitude, it is photochemically dissociated, and so they release the chlorine, and such a chlorine is affected on the ozone depletion in the springtime of the Antarctic regions. So after the discovery of the ozone hole, several supporting the observations have been done. So this is one example done by the airplane, and this is very simple for the latitude and ozone, and also the CLO. CLO is a product that indicating the ozone. So probably flight going from low latitude to the high latitude. So we see the clear ozone depletion around 64 or 5 degrees south. And at the same time, CLO is increasing. That indicate the chlorine is a very critical destroyer of the ozone here in the Antarctic stratosphere. So this is also the result from the satellite, and we are focusing on the first, the upper right picture. This is an ozone observation done by the satellite. So instrument name is MLS, and we see, so actually this is the almost South Pole. The black area is not the data. This indicates the no data area, so this is not real data presented here. And we see the rather small ozone here, and at the same time we see the enhancement of CLO here, and we can say that the chlorine that is originally from the chlorofluorocarbon is destroying the ozone over the Antarctic in the lower stratosphere. So in such a critical condition, the international community established the Montreal Protocol, which is an international treaty designed to protect the ozone layer. So this is a diagram showing the time and equivalent stratospheric chlorine. So how much the chlorine is released in relation to the chlorofluorocarbons. And if we didn't, if we don't have such a protocol, the chlorofluorocarbon amount is released, so the release amount is very rapidly. And so as suggested in Montreal Protocol, this is slightly decreased. So this is a kind of, so we should do this, but it's not so strong. So after that, there are several corrections of this future projection, and now we are in the sense of the zero emission in 2011 about the fluorocarbons. And actually the fluorocarbons, there are many variants. So, and we see that the most fluorocarbons, most of those species are kind of peak and also show some decrease here. And this is a picture taken from the recent scientific ozone assessment of ozone depletion. The first figure of the general summary. And here, this diagram shows the chlorofluorocarbon release, how the release of the chlorofluorocarbon is going in the time series. And after the Montreal Protocol, such a release is rapidly decreasing here like this. So it's a good indicator at the first look. But as I said, that the chlorofluorocarbon is a long-lived species in the atmosphere. It's not so easily destroyed. But as I said, that in the stratosphere, it is slowly destroying. So the equivalent effective chlorine in the stratosphere is not so sharply decreasing, slowly decreasing. It takes about 100 years and so on. And corresponding to these, the decrease of the effective chlorine, the ozone is now slowly recovering. And this is another message, as I said, that here. So now we can see the start of the recovery of the stratospheric ozone. So now I'd like to show some of the computer simulations with Montreal Protocol and without Montreal Protocol. This means that if we take this root. So in that case, the scientist couldn't find answer about the atmospheric phenomenon. So scientists cannot understand why this ozone depletion is happening. So this is a no protocol case, and now we are taking this route, zero emission case. And so again, we cannot see the movie here. I'm sorry, this is a movie, but cannot show you that you can see this web page, the original version of the movie. And in the next figure, this is a summary of the time series of total ozone with and without Montreal Protocol. So with Montreal Protocol, so this is a world we are now living. So owing to the Montreal Protocol, we are now living in the very healthy Earth. And ozone amount, this is an ozone amount in early 2000 and up to 2070. So the ozone is slowly recovering, but not drastically decreasing. So the Montreal Protocol works very well. But without Montreal Protocol, so in that case, as I said, the scientists didn't understand, cannot understand the mechanism of the ozone depletion. After around here, 2020, the situation is not so big compared with Montreal Protocol. But after that, the ozone layer is catalytically destroyed. And around 2030 and also 2040, there is no ozone layer in the atmosphere. So we are very happy. So now we are living in this with Montreal Protocol, but not without Montreal Protocol. So here is a summary of my talk. So the role of the Humanosphere scientist is to aim to investigate the present and future problems in the Humanosphere. So this is a kind of data diagnosis, and theoretically explore treatment of these problems. This is a kind of remediation that will contribute to establishing a sustainable Humanosphere. So very healthy and good condition of the Earth now. So more importantly, such results should be delivered to people in public and political sectors and implemented in proper way, like a Montreal Protocol. An example about the ozone depletion is one of the most successful demonstrations in human history. And so in collaboration with scientists and politics and public people, and it should make the best use of the current problems we are facing, like global warming and due to the greenhouse gases increasing. So that's all my talk. Thank you very much.
Thank you very much for Professor Masato Shiotani for the interesting topic related to our time and the perspective of the RISH-Kyoto University, Japan. Thank you very much. Next, we will hear the second presentation from our second keynote speaker, from Professor Dr. Ernest Riyadiningsih as the Acting Director of National Institute of Aeronautics and Space, National Research and Innovation Agency, BRIN. So I would like to invite Professor Erna to deliver her presentations. So Professor Erna, please, time is yours.
Yes, thank you, MC. Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. I hope you all keep healthy. Thank you so much. And first of all, I would like to thank that the organizer of these important symposiums invite me to speak on behalf of LAPAN. I would share my presentation material from my screen. Sorry. Could you see it?
Yeah, yes,
Okay.
it's very clear.
Thank you. So I would like to raise on important topics, although LAPAN as the oriented and space organizations not really dealing directly with the what you call it most of the participants here is doing in their research. I would like to raise about the importance of space-based science and technology, and to support, particularly to support sustainable development goals and climate mitigations. I would like to introduce, my name is Erna Sradiningsih, and at the moment I'm appointed as the acting head of a new name of LAPAN. Still we have the name of LAPAN, but the acronym is quite a bit different. You know, not a National Aeronautics and Space Institute, but we are now become Aeronautics and Space Research Organizations, and we still have the LAPAN as the name of space agency in Indonesia, and we are now under the National Research and Innovation Agency, or BRIN. In this particular symposium, I would like to share some of the important issues on how not only our organization structure already transformed into a new form of organizations, and but facilities on the scope of our activities. And the second important is that I would like to share about the satellite, importance of satellite Earth observation, particularly to address the issue of sustainable development goals. And I would end my speech with some concluding remarks. First, I would like to to share with you about what are the core activities of the, I would not say that this is the organization, but the program, our national program in Indonesia. This is not only belong to LAPAN, but also belong to BRIN, and also belong to Indonesian as the whole. The core activities of Aeronautics and Space Program in Indonesia, as mandated by Space Act number 21, 2013. This is the legal basis of the activities. And so I would like to to more focus on some of these four core activities. The first core activities is related to space and atmospheric sciences, and I think most of the participants, some of the participants here also dealing with the space and atmospheric sciences. And the second is in aeronautics and space technology, including rocket, satellite, and aeronautics. And the third is in remote sensing, is more for the application of the space-based technology. And we have a national remote sensing data bank and national Earth observation system. And last but not least is in the space policy studies. And from the perspective of organization, that LAPAN has mandate from the Space Act from the 2013 to 2021 or this year. But since the 1st of September this year, LAPAN has been integrated, including with LIPI and other research organizations, become a bigger organization as the part of the BRIN, National Research and Innovation Agency, from September this year, and so forth. And this is the facilities in conducting aeronautic and space activities in Indonesia. So this is kind of what we are going to leverage the application of the space-based science and technology, including to address SDGs and climate change mitigation as well. And with regard to satellite Earth observations, of particularly to address the sustainable development goals, first, of course, we understand, we know that there are 17 goals under the sustainable development goals. And here, some of the goals are contributed significantly by the satellite Earth observation, including the clean water and sanitation, sustainable cities and communities, climate actions, life below water, life on land. And of course, there are also some limited contribution of the satellite Earth observation to support the SDGs, such as zero hunger, good health and well-being, affordable and clean energy, in industry, innovations and infrastructures, as well as responsible consumptions and productions. I would like to share you about how the digital services of remote sensing data and information produced by LAPAN in both in a web-based platform as well as a mobile-based platform. This is including not only the data itself, but also information derived from remote sensing satellite data, as well as from other observation platform. I mean, a terrestrial platform. It is also become our research activities, which is dealing with the sustainable development goals and climate change. First, I would like to share the activities that can support the SDGs number 6, which is clean water and sanitation. And we have activities in the last 2 years. This is our activities to monitor the Citarum watershed. This is located in West Java, and the goal of these activities is to internalize integrated watershed management plans that have been compiled into spatial planning. So this from this figure, we can see that the watershed area is have a very significant changes from year to year, and this is in the bottom part of these figures. We can see that in the central of the watershed now is covered with this settlement area. This is also our research activities that has been delivered to the Ministry of Environment, Forestry and Environment, or KLHK, because this is a joint activities, a national joint activities, and I think also this project also supported by the local government of West Java. Next is still under the SDGs number 6, the clean water and sanitation. We have the activity in land forest rehabilitation monitoring, still around the Citarum watershed in Java. But the goal is not only to monitor, but also to establish the action of replantations of critical land area of the Citarum. Of course, the replantation is not conducted by LAPAN. This is the project under the Ministry of Environment and Forestry from 2013 until 2017. And based on the use of remote sensing satellite data, we can monitor the progress of the replantation to rehabilitate the condition or the water quality of Citarum watershed watershed itself. And next is some activities to support the SDGs number 11, which is sustainable cities and communities. Some of the important activities is we have done monitoring in a particular area of a big city. Some example is in the Surabaya city, East Java, and we monitor the green open space and residential area or the settlement area, and we have an analysis to correlate with the disaster risk potential, and the ultimate goal is how can we decrease the disaster risk index. Of course, this project is in collaboration with the local government, as well as the related ministries and universities in East Java. So based on the data processing, we can just separate the area of a settlement to monitor the development, the increase and decrease and so forth. And we come up with the conclusion that there is a green open space decreasing significantly over this area. And next is activities to support the SDGs number 13. This is the climate actions. There are two major activities that we have conducted so far. First is related by using the remote sensing data. We monitor the agricultural drought potential over Indonesia. So the coverage is Indonesian area as the whole, and in this activities we have a good collaboration with the Ministry of Agriculture and as well as with the other local government in particular areas of Indonesia. And the goal is how to decrease the national disaster risk index. So this is the part of how the disaster risk index could be decreased to have a potential action plan to improve the impact on agricultural sectors in particular. And this is we combine the use of low resolution data with medium resolution data, so that we come up with the information on a monthly basis. Next is still related to the activities to support SDGs number 13. But in this particular activities, we focus on the atmosphere. This is the greenhouse gases monitoring of Indonesia, in particularly carbon dioxide and methane. And the goal is how we can provide the greenhouse gases emissions inventory at the national level, as well as to support the MRV, measurement, reporting, and verification. So we can see from this figure the use of NOAA data. This is a low spatial resolution, but with a very good resolution for the atmospheric parameters. And next, still related to the SDGs number 13, the climate actions, but this is the kind of combination between the space-based technology application and terrestrial-based observation. We have the LAPAN, particularly the Center for Atmospheric Science, have conducted several studies on the impacts of climate change on the coastal areas, for example, in West Java, and also the impacts on the water resources, particularly in tidal areas, and food security as well. And also it is related to vector-borne disease, and the group of the researchers focus on Central Java. And the other research is on urban heat island changes and projections in Indonesia. And LAPAN, through the Center for Atmospheric Sciences and Technology, also has developed Indonesia Climate Change Information System. And the system, we call it Sri Rama. And the result can be used for the authority of national disaster mitigation management, as well as the authority in climatology and meteorology agencies. And this is so the output of this system is both in spatial information as well as numerical informations. Not only a current situation of the climate change and impact, but also this is another area. So this system is designed basically to conduct climate simulations and scenarios by using climate models that is called a qubit conformal atmospheric model. We can have a projection until 100 years, and the application is quite very broad, not only for the climate change study itself, but also for example, development planning, spatial planning, climate change mitigation and adaptation actions, and many sectors as shown in this figure. So this is a kind of system combining the observation system with the prediction system, as well as from the satellite based data. And next is the activities to support the SDGs number 14. This is life and below water. And one of the activity is on a coastal aquaculture site selection monitoring in the Central Java and North Sumatra. And this research is to provide the result of this research is how we can provide the marine resources management and fisheries in the management area. One of the example is we have produced the mangrove distribution area, including its changes time to time. For example, this is the area in Segara Anakan and also in Nias Island, North Sumatra. And this is another activities dealing with the SDGs number 14, life below water. We are using the daily resolution satellite data, but with a lower spatial resolution, but we can provide the information based on the parameter of the sea surface temperature, as well as the chlorophyll content, to provide the potential fishing ground area in Indonesia. And this is quite well developed, and the users also can use this information in a mobile platform, so that the fishermen can easily utilize the information in their daily activities in fisheries or in a fishing to find a fishing ground of any particular area in Indonesia. Next is the activities related to SDGs number 15. This is life on land, and the most significant activities that already adopted by the authority in the Ministry of Forestry and Environment is the forest degradation and deforestation monitoring, by using the data to provide information on the degradation of any forest area. And this is an example in the Sumatra and Riau area. We can see the forest cover in particular area from 2016 to 2017. And what is the goal of these activities is we can achieve to extend the degraded conservation, and also we can monitor the restoration action plan conducted by the Ministry of Forestry and Environment. Next, I think by sharing about some of our activities in our in our institution, I think what we are just want to summarize. Sorry. I think is that the use of satellite-based observations is quite useful and beneficial for addressing sustainable development goals as well as the climate change mitigation. Of course, in doing that, we have a very intensive collaboration with various institutions at the national level, local level, as well as at international collaborations. And we also invite all researchers from all institutions in universities and international organizations to be part of our research activities, our program, to improve the use, to improve and to promote the use of space-based technology and application in addressing sustainable development goals and climate change mitigation. I think with that, I would like to end my presentations. Thank you very much for your kind attention.
Thank you very much for Professor Erna for the sharing in perspective from LAPAN, Brin. But before we close our morning sessions, I would like to invite everyone to join the photo sessions. So please, I would like to appreciate if you can turn on your camera to take the pictures together. So for today, we will help by Dr. Maya, if you are ready.
Yes, I'm ready.
Okay, so if everyone is ready, I think you have to stand by with the smiles again, because we have 8 pages right now. So for the first page first, let me count on 3, 2, 1.
Okay, wait a moment. Okay, next.
Okay, next for the second page, 3, 2, 1.
Okay, next.
Okay, for the third page, 3, 2, and 1.
Okay, wait a moment, please. Okay, we can move to the fourth slide.
Okay, and next for the fourth, 3, 2, and 1.
Okay, wait a minute. Okay, move to the
great.
fifth.
Move to the fifth, 3, 2, and 1.
Okay, wait a moment, please. Okay, for the sixth.
Okay, next for the sixth, 3, 2, and 1.
Okay, move to the seventh.
Great, for the seventh, 3, 2, and 1.
Okay, we will have the last slide.
For the last slide, last page, 3, 2, and 1.
Okay, thank you.
Okay, thank you very much, Dr. Maya, for helping us. And thank you for everyone here. Okay, so great. Now we will continue with the parallel sessions for the presentation from the invited speakers and also from the all presenters. So I would like to just remind everyone that we still have the same breakout rooms as we had yesterday. So we have 4 breakout rooms, namely by PS1 for the biomass conversion, PS2 with the bio-based smart material, PS3 for the forest and environment, and PS4 for the hybrid topic of forest and environment, enhancing mitigation for climate change, radar and atmospheric science, and socioeconomy and in SDGs. So I would like to guide you how to join the next sessions. So if you can click the options of breakout rooms in the below of your Zoom meeting screen. And I think, okay, so sorry, it's namely by PS5 until PS8. So if you click the breakout rooms options, there will be another options pop up into your screen. And if you scroll down, there are 4 options. And if you see the join options in the right side of the breakout rooms name, you can click the join options to join any sessions that you would like to attend. Okay, so I hope it is quite clear. And I would like to remind that all the breakout rooms are open to everyone who wants to join any session. So feel free to join any session that you are interested in. And for those of you who also watch us through the live streaming in YouTube LIPI channel, you can also see all the parallel sessions in the same channel of LIPI YouTube channels. So you can always take a look also to our program book for the detailed schedule of each sessions.
Recording in progress.
MOE? It can predict the MOE in good correlation.
For my result, only 0.7.
0.7, that's the best.
Well, yes.
Okay. Do you also predict the density?
Density, no. I just did for the MOE. For the wood products, for veneer and what? And lumber.
Oh, okay. It's because density has a good correlation here, linear correlation with the MOE. So maybe you can predict the density with NER. And then from the density, you can also predict the MOE.
Okay. Okay, thank you, Dr. Ratih.
Yeah, yeah.
And start for everyone has already come.
Yes.
Okay, we can start. How about Professor Yuliati has joined, Professor Irawan has joined, and then Dr. Adli has joined also, and then Mr. Dimas already joined. Mr. Teguh already joined. Mr. Jauhar has already joined. Already joined or not? Miss Listia. Okay. Good morning, everyone. My name is Imran Arat Sufianto, and I'm your moderator for this parallel session 7, Forestry and Environment 3. I will be helped by Mr. Adik Bahanawan and also Mr. Handoyo and Mr. Fajar as IT team. Okay, we hope for all the participants active to give a comment, a suggestion, and a question for the presenter, because it is very important for them to improve the research. Okay, we start with the, let me share the Yes, this is. Okay, let me start. Let me start with our invited speaker, Dr. Ratih Damayanti. Dr. Ratih Damayanti will give us a lecture about the development of food identification system and timber tracking database to support legal trade. I will read the short bio from Dr. Ratih. Dr. Ratih belongs to Standardization Instrument of Sustainable Forest Management Center, Standardization Instrument of Environment and Forestry Agency, Ministry of Environment and Forestry Republic of Indonesia. She joined in KLHK from 2003. Now she is the head of Lignocellulose Anatomy Laboratory and curator of Silarium Bogoriense at Ministry of Environment and Forestry, based in Bogor, Indonesia. She obtained bachelor and master degree of forest product technology from IPB University, and then PhD in wood science from the University of Melbourne, Australia. As the wood anatomist expert, she has produced more than 100 national and international publications and 20 patents and copyrights, and is member of IAWA since 2019, International Association of Wood Anatomy. Her masterpiece is ICO KLHK. ICO, alat identifikasi kayu otomatis. I think most of you have often heard about it, which is application in smartphone to identify wood within seconds using artificial intelligence and computer vision technology. It has been being developed since 2011 and released in 2019 by KLHK. By now, around 823 of wood trade species are able to be identified by this application. Do you want to know more about ICO? Let's take a look at Dr. Ratih lecture. Pak Agus, please play the video of Dr. Ratih.
Hello everyone, my name is Ratih. I am a wood scientist under the Ministry of Environment and Forestry, the Republic of Indonesia. Today I want to talk about our recent project with the USAID, namely Vertical Aid Development of Wood Identification System and Timber Tracking Database to support the legal trade. Ladies and gentlemen, Indonesia is a mega biodiversity country with about 4,000 wood species grow in the tropical forest. The timbers have a vital role in fulfilling human needs and support countries' economic growth. Therefore, maintaining the sustainability of forest and forest products diversity become a crucial factor. However, international faces some challenges. Data from the International Association of Wood Anatomists journal in 2020, as globally it is estimated that 10 to 30% of the timber trade is illegally harvested. And if only consider timber trade in tropical forests, an estimation between 30 to 90% is more likely. In the red set, there is a legal document that needs to be fulfilled for exporting timber. At the point 11, common and scientific names is required to be determined. It shall be filled with the name of legally logged timber, but our forest industry still have difficulties mainly to fill in with the correct scientific name. The custom also has difficulties in ascertain the validity of the legal document, mainly if there is mixing legally and illegally logged wood. Thus, efficient and accurate identification tools are therefore critical for species identification and also the origin assessment of traded timber, and will likely contribute to protecting forests and their associated biodiversity, and the tool must be embedded in the law enforcement. Indonesia is active in the Asia-Pacific Economic Cooperation Expert Group Forum on Illegal Logging and Associated Trade, or we call it APEC AGILAT, and also Asian Working Group for Forest Product Developments, AWGFPD, and other regional or international meetings for actively voices the importance of global agreement to combat illegal logging and illegal trade in timber forest product. By involving towards this peer cycle project, it becomes one of our commitments at Wood Scientists. Ladies and gentlemen, this is the increase of Indonesian export value to the European Union since 2013, when Indonesia signed FLEGT-VPA with the EU. FLEGT-VPA is a forest law enforcement, government, and trade voluntary partnership agreement between the EU and timber-producing countries to promote trade in legal timber products and help to close the EU market to illegal products. Since 2013, export of SVLK certified timber products has increased significantly, more than 80% with a period of 7 years. Number of importing countries have also increased from 155 countries to 196 countries. It shows international commitment that when Indonesia declares to support the legal timber trade, it also brings positive impact not only to the increase of international trade as other countries appreciate and requires it, but also to forest sustainability. However, during the pandemic, the export values decreased roughly 5%, but relatively stable. And export in the first semester of 2021 has exceeded the export of the 2020. How we know that in legal timber trade, wood identification is very important. However, not everyone can do this. The limitation of existing science, technology, and human resource capacity have caused the process of wood identification to date can only be undertaken by experienced and trained researchers or officers. No tolerance for errors in wood identifications. Many consequences if identification results wrong species, financial losses by industries, government, and threat to the forest sustainability. Another problem is that it is not only can be carried out by researchers or officers not in wood anatomy background. The wood identification process also takes long time, seconds to 4 weeks, depend on the difficulties of the samples. For law enforcement by customs, it needs less than 24 hours to make a decision. And there are also a limitation of the existing wood identification, which cannot identify what the species level, detect work origin, and also estimate the cutting treat time of wood. So all these limitations bring the ideas in developing wood identification system by using various advanced methods through the Per Cycle 8 project. By the research cooperation with Forest Product Laboratory USDA and University of Wisconsin, we applied development of wood identification system and timber tracking database to support legal trade project with 4 main outputs. First, improving the existing automatic wood identification system, we call it a bit ICO-KLHK. And then the second is developing more objective wood identification system by using wood capacitance. And the third is assessment the current wood legality system in Indonesia and implementation or integration of wood identification system into Indonesian Timber Legality Assurance System or TILAS. And the fourth is integrated Lambung database. We start with the output 1, 2, and 4. Yeah, Indonesian tropical wood species were collected in Lambung managed by Indonesian Forest Product Research and Development Center under the Ministry of Environment and Forestry. The wood collection has played an important role in the wood identification process for research, education, as well as bioforensic, which is involving wood as legal evidence. The benefits of Silarium, we can use it for the reference for wood identification for industries, for research, like wood anatomy and basic properties, commercial timber classification, and also for development of automatic wood identification systems, and for legal and custom. Silarium Bogorians is used to identify timber to combat illegal logging and wood identification for timbers as legal evidence. This is the standard methods that we use at daily basis for wood anatomy observations. We already accredited by the ISO 1725, and then it is the steps, 5 steps, commonly from the general observation of the timber, and then we conduct macroscopic observation by using macroscopic magnification 10 times loop. And also continue with the microscopic observations. We observe 160 features under the microscope of the International Association of Wood Anatomy's list of hardwood or softwood. And then the next step is compared to the authentic wood collections. You can see here it is the samples of plywood that we need to be identified, and then the samples, it is and then this the rest is the authentic wood collection. If we already very similar or identical, so we can determine the wood species. Yeah, because of because this constraints, we need the identification needs a long time, and then also it only can be conducted by the experts in wood anatomy. So start in 2011, we try to develop an automatic wood identification systems. We start with the 30 wood species from 5 geographic locations, and then in 2017, 2018, we have cooperation with the Research Center of Bioinformatics, LIPI, and then we launched ICO. It contained 144 wood species in 2018 and wood ID by using the knowledge in 2017. And then the ICO grew up in 2019. We launched the ICO Kaihaka, which contains 822 Indonesian commercial timber. It can be used freely by using through the Google Play Store. And then in 2020, with the help of USAID, we improved the ICO Kaihaka and edging with the 250 wood species, and also develops with 2 languages. And in 2021, this year, we added 100 wood species, including lesson timber, and also the subnet chapter 44 wood custom organization or wood custom organization, and also how to integrate the ICO Kaihaka into Indonesian TILAS. Ladies and gentlemen, it is the benefits of ICO Kaihaka. Firstly, it can shorten time in wood identification from 1 day to 4 weeks to seconds, and then giving objective wood identification result with more comprehensive information. In the ICO Kaihaka, we provide the botanical names, trade name, commercial timber classification, specific gravity, strength class, durability class, conservation status, similarity to the species collected in Florence from specific location, and also potential utilizations. And it's also portable, easy to use, and also can help to accelerate the process of environmental and forestry law enforcement, and help in improving the performance of timber industries. And ICO can also be a learning media for Indonesian wood and also Indonesian wood library sources. And the important things that it can ensure the accuracy and increasing the credibility of legal documents in the Indonesian timber legality assurance systems. This is the phase of ICO Kaihaka in 2019, and next it is the phase of ICO Kaihaka in 2020 with the USAID projects. You can see here there are information of the conservation status. If the timber is classified as endangered or vulnerable, it can give you a clue through the color. Endangered is in red color, so you're aware that the timber you hold is in endangered status of the conservation. You can search many information of wood through the species name or the trade name in the wood library, and you can get the information like this. Until last week, the users of ICO Kaihaka already reached more than 3,600 with a total of 103 wood species. However, for development of ICO Kaihaka, we include good images, because the basic of the ICO Kaihaka is computer vision. So in the left side is example of good images, but in the fact the users sometimes they are not follow the guidelines that we provided, and then
Recording in progress.
remind me for the break room?
Recording in progress.
The large script is visible. So this problem makes the accuracy of the Icon-Lig is relatively low, 0 to 100. Thus, we need to improve it. We need to provide very accurate and objective and also easy with identification systems, and with the collaboration with many scientists from the LIPI, IPB University, SciTech Labs, and also Kyoto University. We try to answer the challenge that we still need a wood identification system that not only can identify the wood species, but also, and it is enhanced to differ wood origin or geographic locations, determining the time when the trees are cut, and also carbon. This is for using carbon dating by using biodeterioration, and also oxygen isotopes. Ladies and gentlemen, it is all techniques or methods to fight the water division that already tried in my laboratory and in collaboration with many scientists. Start with the anatomical structure. This is our daily activities that identify timber with by using the anatomical structures, and then we also try to implement computer visions for wood identifications, and also DNA with IPB University is also try to track the wood origins, and with Research Center of Physics in LIPI, we try to also implement the laser induced plasma spectroscopy, but unfortunately, it's difficult to develop a handy or portable ones. And then we also try the near infrared with the Kyoto University and researcher from LIPI. Yeah, it can be implemented to identify timber, for example, the Soria SPP, but we need a system that's very handy and in easy steps. And then the journey bring us to the development of wood identification by capacity and space with the SciTech Lab H4 technology, Indonesian's private researcher, and also by using Raman spectroscopy with the researcher from LIPI, Danang Sudapoko Adi, and teams. And this is the third of the most sophisticated method at the time, but it's very expensive and cannot be implemented in the forest. So yeah, our goal is how to get a handy, portable, and easy, also cheap wood identification system that can be implemented by officers in the forest and then at the port and so on. So with this USAID project, we developed wood identifier or wider. It is already patented in August 2020. We call it as wider. It's a wood identification tool based on electrical capacitance measurements, and this tool utilizes spectrum analysis up to 10 megahertz and machine learning algorithm to identify wood species. Wider can measure wooden object in just milliseconds and has an accuracy of above 95%. Wider is very suitable for use in the field or inland forest because the tool is portable and powered by batteries that can last quite in a long time. And then for the second generation, we also completed the information, not only the wood species, but also the density, moisture content, hardness, modulus of elasticity, and modulus of rupture as a non-destructive testing to predict the wood basic properties. It is genuine of Indonesians innovations. And this is another bonus from the USAID project. We have ECVT for dynamic tree monitoring system to find out the tree brain. Ladies and gentlemen, the physiological processes of trees are strongly influenced by environmental conditions. By understanding the physiological processes that occur, the appropriate silviculture treatment can be determined. Thus, the stand productivity can be increased. Information on tree resilience to the disturbances can be useful for individual or population selections, interbreeding programs, and climate change adaptation. The technology of ACVT for the dynamic stream monitoring system based on the nature of electrical productivity allows the trees response to the environments to be known in real times. So the process that occur in it can be seen in its entirely, including the part of the tree that is most active and always respond can be studied to find out where the brain of the tree is. It's also already patented in August 2020. And this is the fourth output of the USAID project, is integrated database of Solarium Mugorians. In this integrated database, we can only use one application that allow user to identify wood by utilizing existing identification case without switching to other application, because in this integrated database, it provides the information of origin of food sample, collector's name, collection date, family name, genus name, species name, local name, but storage room, drawer room, timber utilization, specific gravity, strong class, durability class, commercial timber, conservation status, microscopic anatomical feature, microscopic and macroscopic photos, always have information on the microscopic slides and fiber collections. And then we go to the fourth output, that is the assessment, the current wood legality system in Indonesia, and implementation or integration of food identification system into Indonesian tillers. From the very for 2009, an integrated timber tracking tools can detect deforestation and forest degradation, and it is needed. Ladies and gentlemen, Indonesia has SIPO online to monitor logging activities, track timber transportation, control the chain of custody, facilitate enforcement, follow up, and generate reforestation credits. So when combined with system for the authorizations of forest operation and species identifications, it can be used to alert authorization to legal activities and to verify timber legality. So it will strongly support timber legality in the market nationally and internationally, and accelerate the business process of forest industry which support countries' economic growth. Ladies and gentlemen, it is the information we get from the forest group discussion on 9 September from this project with this project teams and also Directorate General of Sustainable Forest Management and the Ministry of Environment and Forestry. The wood identification system can be implemented at three stages from the downstream, upstream, and also market supply that require certainty of what species. The correct information of the wood identification or the wood identity can have implication for the potential loss of government revenue, non-conformance of timber transport documents, forest KSH, and also incompatibility of export document and potential rejection of export products by buyers. And the potential eco-users are GANIS, PH, forest management technical personnel, to issue the inspection report and certificate of legality of forest products, SKSH, and auditor as SPLK actor, and also the exporter. Ladies and gentlemen, there are 8 stages of what identification role are required from the downstream, primary upstream, secondary upstream, and also in the market. There is not so many constraints in domestic or national trade, but for export, buyers always question the wood species in each product's component, and it influences the determination of the HH code. In the processing, in the primary, the log barcodes from the stand inventory before logging is detachable. So this is the condition or the steps when the wood identification is lost in the track.
And then in the transportation process, also in the upstream or secondary stage for further processing, the possibility of wood raw materials to come from multiple sources. So the products may come from various food species, for example, the table products, the legs using teak, the wood rubber using salmon, and using plywood species. So it is very complicated and it needs the help of the wood identification system. Ladies and gentlemen, this is the business process in the Indonesian Timber Legality Assurance System. The SPLK has changed its nomenclature to Legality and Sustainability Verification System, and as a rebranding of strengthening aspect of sustainability. SPLK includes comprehensive verification from upstream, downstream, and the market on a national scale. Some of the exported wood products experience obstacles, including the denomination of the HS code and the wood species. So far, the determination of wood species and HS code is based on knowledge of auditors and business actors. So it is necessary to implement a wood identification tool here. And lastly, there is a need to increase the capacity of auditors and business actors in the use of identification system. So still, there is a long journey for the to support the legal timber trade in Indonesia and also internationals. And that is all for me. Thank you very much for your attention.
Thank you very much for the lecture. ICO has been improved gradually. It is very nice. To all the participants, please question to Dr. Rati. We have two questions. Please. Oh, yeah, Mr. Adli, please.
Yeah, thank you very much for the presentation. Dr. Rati is such inspirational presentation. It's really good. It's lucky for us to having Dr. Rati in here. She is one of the best government officer in the Ministry of Environment and Forestry of Indonesia. So I have several questions for Dr. Rati. So how many wood species can be identified by ICO? That's the first question. And then can we detect the wood species of furniture or wood-based panels? And then does the ICO need internet connection to detect the wood, or can we use offline, something like that? And then final question, can we use the camera phone directly, or do we need additional lens for ICO application? Thank you very much.
Please,
Can I answer? Okay. Thank you very much, Adli, for questions. Just remember me if I forget the question. The first is how many species in ICO KLHK. This year, totally we have 1,392 wood species. It is including the commercial timber, mineral commercial timber, and also imported timber. It is requirement from the SPLK or from the Sustainable Forest Management Directorate General that sometimes they need to determine, and also from the customs to identify the imported timber, because it's also influence the tax that they send the timber to Indonesia. And then the second question is, can ICO identify the furniture? And also you asked about the wood-based panel.
Yes, something like the wood-based panel or furniture. So can we detect the wood species?
Yeah, ICO can be used to identify solid wood. For example, if we have furniture with the different wood species in the part, in each part, we still can identify it, as long as we can find the the cross sections. So everyone who should know where the positions of the cross sections. And then sorry, it's very messy here. We have to cut or to make clean cut with sharp cutter, for example, to get a clean surface, then we can take a picture or macroscopic picture of the cross section of the timber. However, we need additional lens because it is really not focused to if only use the lens for the smartphone. We need additional lens which is very cheap, only 30,000 rupiah. You can get it online. And then here Icon-Lig, usually we recommend to use it as online because Icon-Lig is always improving. But if for example, if the officers of the custom they work in the forest or in the port where the internet connection is limited, we also provide offline Icon-Lig, which is a fixed number of the system, and the accuracy is the same with the online version. And then the last question is what I forgot the question. Sorry, Adli.
I think you already answered it. We do we need
already,
additional lens for the Icon
Yeah.
application? Yeah, you said that we need the microscopic lens. Okay, thank you very much.
So the key in Icon-Lig, you should provide a very good picture, so you can get a good accuracy by using this system.
Thank you.
Thank you, Adi.
Okay, participant, one question, only one question. Is there a question? One question, please. Yes, please, Miss Awi.
Okay, thank you, Burati. It's really exciting about this Icon. Since Icon is a tool, does it how can we say to make sure its accuracy every 2 years or 3 years calibration? That's what I want to ask. Does it need any calibration to make sure the accuracy of the Icon? Thank you.
Thank you very much, Privi. Yeah, for the Icon-Lig, we always doing validations for the wood species, and then we also try to have like a trial with the users. For example, so for people in the forest industries, we ask them to try the Icon-Lig, and then we also provide with the guidelines. So we can make sure that they follow the guidelines and to get the very good image. And then the accuracy of the Icon-Lig is, yeah, I already said that it is 0 to 100%. It depends on how the user use it, how the user make their picture, because sometimes that the users they are not be patient to make a good slice and then make a good taking a good picture. They usually sometimes as soon as just use the Icon-Lig and then take a picture with their handphone. They need or they want to have a good result. So the key here is we use Icon-Lig following the guidelines, and then we make a very good picture of the macroscopics. And then the important one is the user should know where is the cross sections of the timber.
Okay, thank you very much for Dr. Atif for the answering the question. Thank you very much for Dr. Atif to give us a lecture. We hope that Icon will be getting better in the future. Thank you very much.
Yeah, thank you, Imran. Thank you, Adik, and everyone here.
Okay, now let's go to the next presentation by Professor Yuliati. I will give a short bio of her. Yes, Professor Yuliati Indrayani was born and raised in Pontianak, West Kalimantan. She obtained bachelor degree at Universitas Tanjung Pura, master degree at IPB University, and doctoral degree at Kyoto University. Professor Yuliati earned professorship in 2018 in the field of forest product technology, forestry faculty, Universitas Tanjung Pura. And then she will present the research with the title Low Formaldehyde Emission Particle Board Resistant Against 3 Different Wood Decay Species, written by Yuliati Indrayani, Evi Septiani, Al Hadi, and Wiwi Winarsi. Please, Pak Handoyo, play the video.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. First of all, I would like to thank to the committee for giving me a chance to share my research result. My talk today is about low formaldehyde emission particle board resistance against 3 different wood decay fungi species. This research was done with my colleague, Evi Septiani, Al Hadi, and Wiwi Winarsi. My name is Yuliati Indrayani. We are from Tanjung Pura University. We focus about particle board here. What is particle board? Particle board is a composite product made of lignocellulose material, which are bonded using adhesive. In general, synthetic adhesive based on formaldehyde are used. According to Kumar and PZ, 95% of formaldehyde-based adhesive produce wood-based composite. On the other hand, the use of synthetic adhesive causes formaldehyde emission that impacts humans and the environment, especially when used indoors. According to WHO, a formaldehyde emission level of 0.1 milligrams for 30 minutes of usage can lead to heart problems. An effort that can be made to reduce the formaldehyde emission in composite product is adding activated charcoal. Activated charcoal is charcoal that has been chemically or physically activated to have a high absorption capacity with varying carbon content. Previously, research on the use of activated charcoal in composite product only discussed its influence on formaldehyde emission, physical properties, and mechanical properties of composite. Meanwhile, the effect of adding activated charcoal to the composite on biological properties has not yet been reported, especially to wood decay fungus. Previous study used wood as raw materials in production activated charcoal. Meanwhile, there has been no mention of the use of bagasse in production of activated charcoal on bagasse particle board. And why bagasse? Bagasse was selected for this study because it was readily available, inexpensive, and didn't pose a health risk. And later it may be used to reinforce composite as a sugarcane fiber, which can help to solve environmental issues. Therefore, the aim of this study was to assess the resistance of particle board made from a mixture of bagasse and sawdust with varying amounts of formaldehyde emission to wood decay fungi. As the materials, we use bagasse, sawdust, and for the adhesive solution, we use urea formaldehyde with solid content 52% and concentration of 12%. For the activated charcoal is made by carbonizing bagasse at 300 degrees Celsius for 2.5 hours, followed by carbon activation using HCl solution for 24 hours. The target density of particle board is 0.7 gram per centimeter cubic with a size of 30 by 30 by 1 centimeters. The particle board manufacture was done by mixing activated charcoal, sawdust, bagasse, and UF adhesive. A mixture of 0.1% catalyst and 1% of paraffin. The levels of activated charcoal added to the particle board were 2%, 4%, and 6%. The composition of sawdust and bagasse were 75% 25, 50, 50, and 25, 75. The board was pre-pressed for 1 minute, then hot pressed at a temperature of 140 degrees Celsius for 10 minutes with a pressure of 35 kilogram per centimeter. After that, the particle board was conditioned for 7 days at room temperature before testing to the wood decay fungus. The testing method of wood decay fungi was based on SNI standard with some modification. The media of the test used was 39 grams of PDA dissolved in 1 liter of distilled water. 100 milliliter of PDA solution was put into each bottle and then sterilized using an autoclave at a temperature of 121 degrees Celsius with a pressure of 1.5 atmosphere in 30 minutes. We use 3 species of wood decay fungus, Thyramyces palustris, Cariolus versicolor, and Schizophyllum communi. Above the PDA media, wood decay fungus was inoculated and stored in the incubation room until the mycelium grows and thick on the surface of the PDA media. Then the test sample, which has been known its initial weight of oven dry, was put in a bottle containing the wood decay culture. Each bottle was placed with 1 test sample, and it was done for 3 species of wood decay in separate bottles. The bottles containing the test sample was incubated for 12 weeks at a temperature of 22.7 degrees Celsius and 50% humidity. 3 lip replication was run for each species of wood decay fungi. Here we can see some picture. The left one is wood decay biocide, and next is board with activated charcoal and wood control at the beginning of the test. And the next is board with activated charcoal for after 3 months exposure to wood decay, and wood control after 3 months exposure to the wood decay. Now we come to the result. The particle board used in this research was varying levels of formaldehyde emission as presented in this table. The table shows that more activated charcoal added in the particle board manufacture caused lower the formaldehyde emission level. It can be explained because the activated charcoal in particle board can absorb the free formaldehyde of ISSH so that formaldehyde emission become lower. And this slide shows the value of weight loss of particle board after being tested on CSC, COP, and TIP. The average weight loss of samples after exposure to wood decay varied as shown in this figure. In general, it can be said that the lower the formaldehyde emission level causes lower the sample weight loss. The sample with low formaldehyde emission had a higher content of activated charcoal, so that the sample contained more pure activated carbon. Consequently, wood decay fungus didn't like the sample. In these studies, characteristics of activated charcoal of bagasse were 10.54% moisture content, 6.12% ash content, and 66.68% pure activated carbon. It is known that white rust fungus degraded the lignin chemical components, while the brown rot fungus degraded cellulose and a small amount of lignin chemical components to obtain their food. The activation process of charcoal into activated charcoal could increase the absorption ability of activated carbon itself. Absorption properties could attract other substances around it to interact and bound to this substance, And this absorption process could occur between solid and solid or between solid and liquid. It may cause a bond between cellulose and lignin on particle board with activated charcoal, and as a result, wood decay fungus didn't recognize the cellulose and lignin as their food source. And this slide presents the wood samples after being tested on wood decay for 3 months. The upper side is white ratio V, the middle is SC, and the bottom is TIP. As the conclusion, the activated charcoal of bagasse could be used as an antifungal materials for wood decay fungus based on the weight loss of the test sample. A high level of activated charcoal could resist the attack of wood decay fungus, and it was an environmentally friendly materials that was not harmful to humans and the environment. And further research is needed to examine low formaldehyde emission particle board to thermal resistance to develop wood decay fungus and thermal resistant particle board technology. The authors are grateful to Tanjung Pura University for funding this research. Thank you for your kind attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for Professor Yuliati for the presentation. We have 4 minutes for discussion. Please, participant, give a comment, suggestion, or question, please. Okay, Dr. Adli, please, as your field, this is, please.
Thank you very much for Yuliati for the presentation. I just want to ask some question. I saw the value of the formaldehyde emission is really high. Do you know what is the ratio of formaldehyde and urea? Because it's really high. I think it's over than 2.0. So I want to know what is the ratio of the formaldehyde to urea mole ratio you use for the UF resin. And then what is the catalyst you use for the UF resin? Is it a conventional ammonium chloride or other catalyst? Because you didn't mention in the presentation. And then why you just use only 0.1% of the catalyst? Because normally in industry they use 3% of the 3% amount of the catalyst based on the UF resin solids content. Thank you very much.
Please, Professor Yuliati, for answer the question.
Sorry, still on mute. I'm sorry. Thank you, Mr. Adli, for your questions. You have 3 questions for me. So the first, why you asked why formaldehyde emission is still high. So yeah, this is the previous research for us. So we use a very small amount of activated charcoal. So 2 and 4 and 6%. So based on this research, so we have to do for the research how to more reduce the high emission formaldehyde emission in this particle board. So maybe for the research we have to add some additional chemical, or we have to much more add some activated charcoal by using different materials beside the bagasse, maybe something like that. So yeah, this is enough stop until here. So we have to more detail about how to reduce the emission of formaldehyde until. So we know that it is impossible to make the formaldehyde emission until 0. At least we can only how to reduce, how to reduce, become lower than we use the commercial adhesive without the adding of the activated charcoal. That is the first question. And then why I use because basically we want to use at least pure adhesive without a little bit amount of the additive materials. So why we use only 0.1% of the catalyst. So we use the commercial catalyst we get from the adhesive fabrication in the Pontianak city. So they sell their product to the PT Erna. We know PT Erna is the big the perusahaan besar in Pontianak. So we use small amount of the catalyst, and then we get that from the DPN of the adhesive fabrication in the Pontianak city. I hope that can answer your question, Mr. Adli.
Thank you very much, Prof. Yuliati. Maybe next time we can try work together, because in my research group, we synthesize the UF resin by ourselves. So we choose, we can, how to say, we can synthesize the ultra low emission of urea formaldehyde adhesive, and we just register the patent, and then we can use that maybe in the future for the work. And that's the formaldehyde emission from the particle board is around 0.15 milligram per liter. It's really low. But if we use the commercial one in the market, Indonesian market, it's really high because they don't follow the standard of the emission in Indonesia, something like that. But if they want to export to Japan, they will reduce that and use the F4 emission, lower than 0.3 milligram per liter, something like that.
Okay, that is good news for us. Yeah, so maybe we can make some collaboration research in the future, Mr. Adli.
Thank you, bro.
Thank you. Okay, please, Dr. Ratih, ask directly. Only one question. I allowed you only one question, please, Dr. Ratih.
Okay, thank you, Professor Lili. So we just want to know what is the connection between the activated charcoal and then also with the formaldehyde and the weight loss, because you make connection between the weight loss and the formaldehyde, and how is the roles of the charcoal here?
Okay, thank you, Mr. Dr. Ratih, for your question. So the correlation between the activated charcoal to the formaldehyde emission, activated charcoal can absorb the free formaldehyde from the adhesive. So that is make it the formaldehyde emission from the composite of particle board become lower. So that is the point of the function of the activated charcoal. And then correlation to the weight loss of the fungi, because we know that the activated charcoal can interact some compound of the wood, something such as the cellulose and lignin. So this can cause the bond between the activated charcoal, pure the carbon from the activated charcoal, and the cellulose and lignin, so that the fungi cannot distinguish the cellulose and lignin as that food source, because already changed the structure of the chemical component of the wood in the particle board.
Okay, thank you.
You're welcome.
Okay, thank you very much for Professor Yuliati for the presentation. You can give applause in the reaction chat. Okay, we next move to the next presentation by Dr. Adli. I will give you the short bio of Dr. Adli. Here is Mr. Muhammad Adli Hadi Lubis, PhD. He was born in Medan, 1989. He obtained bachelor degree of forest product technology in IPB University, and then master and doctoral degree from Kyungkook University, Daegu, South Korea, in the field of wood adhesive. He is researcher in Research Center for Biomaterials, National Research and Innovation Agency, BRIN, since 2014. As an active writer and expert in wood adhesive, he has published 26. I'm sorry. Okay. I'm so very sorry for the participant. For the next presenter is Professor Irawan. Yeah, I'm really sorry. Okay, sorry to Professor Irawan. I will read the biography of Professor Irawan. Professor Irawan Wijaya Kusuma. He obtained bachelor and master degree from Universitas Mulamarwan and then doctoral degree from Ehime University in 2005 and professorship in the field of forestry science in 2020 from Universitas Mulamarwan. Professor Irawan will present the research title with enhanced adhesion and reduced formaldehyde emission of urea formaldehyde resin bonded plywood panel using intercalated monomorulinite and laponite nanoclay. It is written by Apri Harris Siswan. I'm sorry. Loh. Oh, this time?
The participant, okay. No. It's correct.
Why?
By Mr. Adli. So you can back the profile software. And then.
Oh yeah, I think I'm mistake. Yeah. Sorry.
Yes.
Oh yeah. Okay. Sorry.
No. Now we are going to.
Sorry, Mr. Adli. Yeah, I think I pushed.
And then
by mistake. Sorry. Okay, I think I pushed by mistake. So Mr. Adli will present the presentation. I'm very sorry. Okay, Mr. Adli. 26 article in peer-reviewed journal Index Scopus and Web of Science. Okay, and then Mr. Adi will present research with title Enhanced Adhesion and Reduce Formaldehyde Emission of Urea Formaldehyde Resin Bonded Plywood Panel Using Intercalated Monomorulinite and Laponite Nanoclay. It is written by Apri Hari Iswanto, Muhammad Adli Rahandi Lubis, Samit Monahar Yodaf. I'm very sorry to Dr. Adli and the team. Please, Pak Handoyo, play the video 702. Thank you.
Everyone, I'm Muhammad Adli Rahandi Lubis from Research Center for Biomaterials, National Research and Innovation Agency, Indonesia. Today, I would like to share my work together with Dr. Apri Heri Iswanto from Sumatera University, Indonesia, and Dr. Sumit Manoharyada from Forest College and Research Institute, India, with title Enhanced Adhesion and Reduce Formaldehyde Emission of Urea Formaldehyde Resin Bonded Plywood Panel using intercalated monomorulinite and laponite clay. This is the outline of this presentation. I will tell a brief of introduction, and I will tell you the objectives. I will show the methodology, and I will tell what are the results, and finally, what is the conclusion from this study. Wood adhesive market reached $16.2 billion in 2020, where Asia is the main consumer with $5.3 billion, followed by the Europe and the Middle East and America. The urea formaldehyde, melamine formaldehyde, and phenolformaldehyde are the formaldehyde-based adhesive that are the main wood adhesive used in the manufacture of wood-based panel. And then followed by the isocyanate and its derivatives such as PMBA and polyurethane and other adhesives, especially bio-based, such as latex, lignin, tannin, organic acids, protein, and carbohydrates. Urea formaldehyde resin has been broadly used as wood adhesives in manufacturing of wood-based composites such as particle board, plywood, and MDF due to its low cost or cheap, fast curing, good performance, and clear glue line. However, there are some limitations such as low moisture resistance or water resistance and formaldehyde emission. Usually, the most common approach to minimize and lower the formaldehyde emission of UF bonded products is by lowering the formaldehyde to urea or Fu ratio for the synthesis of the resin. However, UF resin with low mole ratio have slower curing rate and poor bonding strength. It's also been reported that there is a crystal structure in low Fu ratio, which lower the bonding strength of the UF bonded products. Today, introduction of nanotechnology has opened new opportunity to develop adhesives with better properties and low emission. The intercalation of nanoparticles in the UF polymer can lead to a simultaneous improvement of different material properties. Therefore, this study has two objectives. First, to enhance the adhesion performance of low molar ratio UF resin with modified nanoclay, and to reduce the formal emission of UF resin with modified nanoclay. These are the materials used in the study. We use two types of nanoclay, monomerilionite and LAPAN, and then we use copper chloride and sodium chloride to modify the nanoclay via ion exchange method using these transition metal ions. And then for the synthesis of UF resin, we use the technical grade of urea and formalin, and then formic acid and sodium hydroxide to adjust the pH to the synthesis of UF resin. To fabricate the plywood, we use Sengon wood fillers. These are the methods to modify the pristine nanoclay. So first, the neat or original or pristine nanoclay will pour in the beaker and then mix with the solution of sodium chloride for 40 hours and then filtered. After that, we filtered the solids and liquid, and the solid went to the oven. After that, the solid fraction was mixed again with copper chloride. And this time, we call it the transition metal ion modification. The copper chloride will be used as the TMI, transition metal ion, and then there is an ion exchange method between the copper chloride with the UF resin. And then we filter the solids, separate the solids and the liquid, and then oven the solid fraction, and then finally the solid fraction will cross and sieve into the nano-sized clay. For the modification of UF resin nanoclay, the nanoclay were added at 5% level during the synthesis of UF resin. We call it in situ modification. So after the reaction between formalin and urea, it really goes for methylation reaction or addition reaction. At this time, 5% of nanoclay were added into UF resin, and then they react. After that, they will go for condensation reaction, and at this condensation reaction, the nanoclay will disperse and enter the gallery of the UF resin polymers. After that, the second urea will be added, and to the UF resin will be formed at this illustration. For the characterization of nanoclay and modified UF resin, we characterize the basic properties such as solid content, viscosity, gelation time, and pH, and then the change in functional group using FTIR spectroscopy and the crystal structure using X-ray diffractometer or XRD. For the preparation and evaluation of plywood bonded with modified UF resin, this is the condition we use. So first, we mix the UF resin with 3% of ammonium chloride as the glue mix, and after that, the glue was spread on the fillers at 170 grams per square meter of the spray. And after that, do the cold press for 20 minutes at room temperature, and then it went to hot pressing step for 4 minutes at 120 degrees Celsius. And after that, it will be conditioning for 2 weeks. For the evaluation of the plywood properties, we did the evaluation according to the Japanese agricultural standard number 233, and then we evaluate the tensile strength and the formaldehyde emission plywood. For the result, first I will explain the characteristics of the nanoclay. So in here we can see the difference between the original nanoclay or pristine nanoclay and after the modification with transition metal ion. In this case, we use copper chloride. So as we can see in here, the red line is the monomerilonite and the green line is LAPAN. They have the diffraction angle around 7.5 to 8 with this spacing value of 1.14 and 1.21 nanometer. After the modification with the transition metal ion, the gallery of nanoclay is expanded, it's swelling, and then the displacing value increase. Therefore, the diffraction angle is getting lower. So the modified lapunite decreased the diffraction angle to around 6.9 with displacing value of 1.28 nanometer. In this case, we can see that the modified monomerilonite has the lower diffraction angle around 5 theta with the longest dispacing is around 1.76. That means it's very big gap of the gallery, 1.76 of nanometer. And then the change in the functional group in here, we can see that the modification changed a bit of the nanoclay functional group, especially on the surface of the nanoclay, where the hydroxyl group is more exposed. For the properties of the modified resin, so the original resin was compared with the modified one. So the original or mid resin has a source content on 60%, dilation time 220, viscosity 250, and pH 7.9. After in situ modification with the pristine and modified nanoclay, no change in the pH because we control it at the end. But the solids content increased up to 5% to 75 and 74 or 75% with addition of pristine and modified nanoclay. The gelation time increased with addition of pristine nanoclay to 300 seconds and the viscosity also. But with addition of modified nanoclay during the synthesis, the gelation time decreased. This is probably due to the presence of copper ion, the TMI, the transition metal ion, that catalyze the curing of the UF resin. Therefore, shorten the gelation time of UF resin. And the viscosity significantly increased to 370. No change in the pH. And for the FTIR spectra, the functional group is quite same because probably they are, it's the dominant reaction is the physical reaction, the absorption, dispersion, something like that. But there is an effect of the catalyzing from the modified of nanoclay, as I explained before. So this is the illustration for the catalyzing effect of the TMI. We use the copper chloride. In here, copper ions will react with hydroxyl groups on the surface of nanoclay and release protons. These protons will have the will reduce the pH a little bit of the solution in the UF resin system and then help the UF resin for curing. So, and then for the result of the XRV, we can see in here the original UF resin has 4 peaks. You can see in here the black line, 4 crystal peaks, 1, 2, 3, 4 at this theta. After modification with pristine nanoclay, with monomerilonite and lapunite, the red and green line, they still have that peak, but reduce the intensity. But with addition of modified nanoclay, we can see the change remarkably in here. The modified lapunite still has the crystal peak, but with in situ modification with modified monomerilonite, it partially underpose the blue line in here. So using the curve fitting method with Gaussian function, we can calculate the crystallinity, and then we get the amount of crystallinity in here. Yes, it's decreased with addition of nanoclay, but the significant decrease of the crystallinity was found with modified monomerilonite, which reached around 29% of crystallinity. It reduced almost 50% of the crystallinity of the resin. As a result, when we applied at a plywood, all the plywood bonded with modified resin with nanoclay, it has greater tensile system value compared to the original UF resin or control. All of them reach the minimum standard of 0.7 for dry tensile strength, but for wet tensile strength, only UF resin modified with nanoclay, monorilonate or LAPAN, which met the requirements. For the formatted emission, all plywood bonded with the UF resin modified with either pristine or modified nanoclay has lower formatted emission compared to the original UF resin. But the lowest one was obtained with modified UF resin with monorilonate. So as a conclusion, the net UF resin is constantly about 54% after curing, but with modification of nanoclay, we can reduce to 29.3% using modified monorilonate and 47.5% using LAPAN. So these have the prevention of the crystallization of resin with 5% addition of modified monorilonate. And if it subsequently improve the adhesion strength of the plywood by 3.6% compared to its original, it's around 1.37 megapascal, and lower the format emission by 56.1% to become 0.73 milligram per liter. So in this study, we believe that the modified monorilonate have been intercalated in UF resin polymer matrix during the synthesis, as illustrated before, and partially block the crystal formation, cure UF resin. This could facilitate the formation of three-dimensional cross-linking structure in UF resin and lead to a better adhesion per strength and reduce formatted emission of plywood bonded modified UF resin. Thank you.
Thank you very much for Dr. Adli for the presentation. We have 1 minute 10 seconds for the discussion. Please, audience, for the question, suggestion, and comment to the research from Dr. Adli and team. Please. Oh yes, Mr. Adli.
Thank you, Mr. Raymond, and thank you, Dr. Adli. Very interesting visions. Maybe I miss. I want to question. I have a question. Firstly, about nanoclay. This is good. Could have good positively to be developed. My question first is maybe this nanoclay can be flame retardant. And second one is maybe sure about the compressive strength or bending strength, not just tensile strength. And have you measured PDI? I think about polydispersivity dysphoria. Maybe. Thank you.
Okay. Thank you very much for Mr. Adik for the question. So we have two questions here. First, can nanoclay be a flame retardant in this composite? As it's inorganic materials, it can be used. But in this case, I didn't measure or determine the flame retardancy of this retardant in UF resin products in here. But it can be used. Of course, if you read several journals, nanoclay can be used as a flame retardant because it is inorganic materials. And then for the second question, it's related to the other properties of the plywood in here. Unfortunately, I didn't measure that properties such as bending strength, compressive, something like that. No, just the important thing is the tensile strength for the plywood and the emission. That's quite enough for to check the adhesion strength and also the emission of the plywood from UF bonded products. And then for the PDI, for dispersity, something like that, we already have that, I think, with one of my college, Eko Setio Wibowo. We have a journal we have an article in a journal in that journal, we measure the molecular weight distribution and then polydispersity. We measure that using a gel formation chromatography. But unfortunately for this study, no, because we just want to know the effect of the addition of nanoclay to adhesion strength and also formaldehyde emission. Something like that.
Thank you, Dr. Ali. Very interesting.
Thank you very much.
Okay,
I give you a chance. One question, only one question, short. Again, please, audience. From KLHK, Unmul, many. Please, one question, short. Yes, please, Mr. Gunawan. Whoa,
okay.
Whoa. Yeah.
Okay. Thank you. Is my voice is clear?
Clear, very clear.
Thank you, Mr. Lubis. I have two questions. The simple question. The first one, about in Indonesia, where do you think about the source of material nanoclay in Indonesia, the raw material? The second one, how do you think about the chemical bond between UF bond? Is my voice? Okay, about the chemical bond between UF bond and nanoclay. That's all. Thank you.
Okay, thank you very much for Mr. Gunawan for the question. It's really good, especially for the first question. I still don't know about the nanoclay source in Indonesia because we still import the nanoclay. But for clay is many. For clay, only clay or Lambung, we have many sources in Indonesia. But for nanoclay, I think we still import the nanoclay, especially from BYK company. And then for the second question, as I mentioned in the presentation, so there is the main interaction between UF resin and the nanoclay is the physical interaction. There is a dispersion of the nanoclay into the UF polymer matrix, and then it's entered the gallery of the between the gallery of the UF resin. Also, there is a small effect of the chemical reaction from the modified nanoclay, not the nanoclay, but the modified nanoclay. In this study, we modified the nanoclay using copper chloride. So the copper ion will react with the hydroxyl group on the surface of nanoclay, and it will reduce the pH. This pH, with the lower pH, will trigger the curing of the UF resin, something like that. Only that reaction, not direct reaction between the nanoclay with the resin.
Very clear. Thank you.
Thank you very much.
Dr. Widya, only one question, please. One question only.
Okay, thank you. I'm sorry, I am late to enter this session, but I just curious about you state that in nanoclay there is a physical interaction with UF resin. How about if not in nano size clay, only clay, but it will modify it? How do you think about the reaction? Is it the same or not?
I don't know about that. Thank you very much, Dr. Widya, but I don't know about that for sure, Dr. Widya, because clay, we don't know the size of the clay, but we can try that direct modification of clay. So we have the source many in Indonesia, so we can try to modify that, or direct use of clay in UF resin during UF resin synthesis, or after it's synthesized, post modification. So we can try maybe later if we get the clay, and then we can modify it, and then we can do the modification during the synthesis or later after the synthesis. Maybe we can try that, but I never tried that before, Dr. Widya.
Okay, thank you.
Yeah, it's really good. Thank you very much.
Okay, thank you very much for Dr. Adli for the presentation and discussion. Then we go to the next presentation. This one is from Professor Irawan Wijaya Kusuma. Professor Irawan Wijaya Kusuma obtained bachelor and master degree from Universitas Mulamarwan, Samarinda, and then doctoral degree from Ehime University in 2005. He earned professorship in the field of forestry science in 2020 from Universitas Mulamarwan. Please, Pak Handoyo. Professor Irawan will present their research with the title Bioactivities and Phytochemicals of Some Ferns from East Kalimantan, Indonesia. It is written by Aslihatul Mahmudah, Irawan Wijaya Kusuma, Arlinda Kuspradini, Widya Fatriasari, and Eni Rosama. Please for presentation.
Assalamualaikum and good afternoon, everyone, distinguished speakers, participants, and committee of this conference. I'm Irawan Wijaya Kusuma on behalf of our team. Please let me share you our research entitled Bioactivities and Phytochemicals of Some Fern from East Kalimantan, Indonesia, in collaboration between Mulamarwan University and the Research Center for Biomaterials, National Research and Innovation Agency. So my presentation will be divided into several parts, including introduction, material methods, result in discussion, and also conclusion. For the first slide, I would like to share you about the number of these species. Fern is like a small plant and the bridge between lower and higher plants, and very interesting. It is estimated in the whole world about 10,000 species exist. And interestingly, in Indonesia, we share about 22% of species in comparison to the world fern biodiversity. It's about 2,200 species and spread out whole of Indonesia, including several forest area like the swamp forests, mangroves, secondary and primary forests. While our research has several backgrounds for example, we found that several studies shown that fern from several species has interesting bioactivities, including antioxidant activity, and several interesting phytochemicals also found from these species. Several species also not only for food or ornamental purposes, but also share the medicinal purposes, including good menstrual and nervous disorders, and interestingly for the anesthetic agent also. Several other species also possess antimicrobial activities against several pathogenic fungi. So this would be very interesting for us to share, to investigate more about the bioactivities, and in line with our effort to discover natural antimicrobial, we collected and tested the 8 species of fern, especially for their antimicrobial potential. And our experimental process divided several parts, and we used sample preparation, and we collected 8 samples from the field in East Kalimantan. After that, we identified the identity of the sample, and we made the extraction by methanolytic extraction. And then we follow the several analysis, including phytochemicals, antimicrobials, and toxicity. With the procedure like we collect the sample, drying, ground into powder, and after that we make extract. After that, we got fruit extract, and followed by for the investigation. For the phytochemical analysis, we used qualitative analysis to check the presence of alkaloids, steroids, and so on. While for the antimicrobial assay, we used the simple agar-well diffusion assay against 4 microorganisms pathogenic for human, Candida albicans, Propionibacterium acnes, Escherichia coli, and also the Streptococcus subrinus. For the toxicity test, we use brine-stream lethability test using artemisinin, saline, and naphthalene. This is a very standard procedure following the Mayer method. Now we enter the result of this research, including the phytochemicals and the microbial and toxicity analysis. First, we found that from the 8 species of the fern, we found the occurrence or the presence of several secondary metabolites, including coumarin, tannin, steroids, and carbohydrates, while only 1 species, Acrosticum aureum, showed the occurrence of carotenoids. This will be the base for analysis of the antimicrobial activity. We check the activity against yeast-like fungus, Candida albicans, that also pathogenic for human. We use chloramphenicol as reference compound, and we found that 4 species showed interesting activities: Pteridium, Acrosticum, and Ceratopteris and Blechnum orientale. These 4 species show good about 30 to 50% inhibition in comparison to the reference compound. Furthermore, we found that for the Propionibacterium acnes, we found 4 species also with the same species as like Candida albicans also inhibited this bacteria. Propionibacterium acnes is one of skin bacteria that usually cause inflammation in our skin, including our face. And we found that Pteridium, Acrosticum, Ceratopteris, and Blechnum orientale also possess good activity against this bacteria. Furthermore, we check also the activity against Escherichia coli, and more species showed more activity. We found 6 species: Pteridium, Acrosticum, Lygodium, Lycopodium, Ceratopteris, and Blechnum orientale. Against that 4 species, I mean Pteridium, Acrosticum, Ceratopteris, and Blechnum also possess the activity. So like a wide range of activity that possessed by that 4 species. While for the last, we check the activity against Streptococcus sobrinus. We found that 5 species, Pteridium, Acrosticum, Lygodium cercinatum, and again Ceratopteris talictroides, and also Blechnum orientale. So we found that from the antimicrobial activity against 4 pathogenic microorganisms, we found that 4 species were very strong, were potential to be further investigated. And it may be will be related with the phytochemicals of the species. And it is interesting that because some coumarin, some tannin also present there, and our homework, our task, that to find what phytochemical is responsible for the extract of these ferns. Of course, more bioactivity assay, more bioactivity check for the more microorganism will be needed for this research. How about the toxicity of this sample? We found that from the 8 species of fern, we found no one species that belong to toxic or very toxic. Instead of moderate toxicity, we conclude that 3 species, Pteridium, Blechnum, and Salvinia, belong to non-toxic, and Acrosticum speciosum and Acrosticum aureum belong to less toxicity, and moderate toxicity for the 3 others. So it's very interesting information, very good information that we can further investigate the species of the fern, because seems that we have good information about the toxicity of this sample. So that's for our present research, that will be the base, will be initial information for us to continue this research. Of course, this very preliminary investigation and need more step to evaluate, to prove, and to determine what chemicals that are responsible, and how about the doses, how about the possibility to use this fern species as candidate for the antimicrobial agents. This is still a long step or long phase for our work, and we will do in the near future. And finally, I will conclude this presentation from the 8 fern extract that we collected. We have 4 species very interesting that exhibited all of the microorganisms tested, while we found also they consist of has also potential secondary metabolite, including coumarin, tannins, and so on. And interestingly, that no species that belong to toxic are very toxic. And this will be my closing of this presentation. And finally, I would like to thanks for our team, also the grant from the Ministry of Culture, Education, Research and Technology. And also we like to thank our colleagues, the late Dr. Sugiarto, and also this committee of conference. Thank you very much. And I would like to have your opinion about this research. Thank you, and see you this presentation. Thank you.
Okay, thank you very much. Thank you very much for Professor Irawan for the presentation, and be ready for the discussion. We have 4 minutes for discussion. Please, participant, give a comment, suggestion, or question for Professor Irawan. Please, Ruzu. Okay. Yeah, please, one question only, Mr. Adi. Yes.
Thank you, Prof. Irawan. It's very nice to you. My question is, maybe I missed it. How about the result of the data about the factorial combination between toxicity and efficacy of this extract? Thank you very much.
Okay, so answer?
Yes, please, Prof.
Okay, thank you, Pak Adi. It's a nice question. I try to not to mistake to answer. Is it like how to relate the interaction between the toxicity and the efficacy, or biology?
Yes.
Yeah, unfortunately, I cannot satisfy you with this answer because, yeah, usually we try to find the most effective plan and the lowest toxicity. So it means like how to get the most potential activity with the safety consideration. So I'm sorry that I didn't check the factorial, but we usually in the biological activity test or research, we make like negotiation consideration. Usually when the plant has very high bioactivity and very potential, but also possess high toxicity. So usually we reduce the priority and we will choose the medium one. But of course, there is another consideration. Some research, also the mayor as the founder of this method, also say that the toxic result not always means the poisonous compound. For example, I checked some zinc also. Zinc also possess high toxicity, but we know that zinc usually is safe for us. But this is like another side of toxicity. So we should also consider about the first main consideration. But for this research, we are glad that no one that belong to toxic. That is the main consideration. It means the low doses only to make the high toxicity is not good information for us. That's for my answer, Pak Adik. I'm sorry that maybe not satisfied.
Thank you. Very satisfied. Thank you for your
Okay.
answer.
One question for Professor Irawan. There is a time still. Whoa, two participants. Yes. Mr. Gunawan. Yes, please, your question.
Okay, thank you. The short question. Hello, Prof. Irawan. Nice to meet you again.
Yes,
I just want to know about the group of your the fund you research, Pak. Is it any species from edible fern? That's all, Pak. Thank you.
Yes, some of them, including the edible one, of course, including like Lignocellulose circinatum that we also familiar from 8 species. We also have edible, but the main consideration of these 8, actually, I should inform you that we try to assist our colleagues in the Institute of Agriculture in East Kalimantan that they focus on the mangrove species. So 8 species were collected from the mangrove. So we found that interesting result. I show that beside from food, ornamental, and also for the medicinal purposes, these species, some of them edible, but some of them we don't know yet, because people still, usually we get information from the local people actually. But interestingly, maybe another side of this research is the phytochemicals are different, because maybe the mangrove condition, the salinity and so on. So I found it's like unique, and maybe firstly, I think that I did mistake about this result, but maybe the mangrove species that still need more elaborated. Thank you, Pak Gunawan. It's a long time.
Thank you, Prof.
I'm not see you again.
One short question. One short question. Is there any one short question? We have 1 minute. One short question. Okay, if there is not, thank you very much for the Professor Irawan for presentation and discussion. Thank you very much.
You're very welcome. Thank you very much.
Then we go to the next presentation. Okay. Sorry. Okay, for the next presentation, will be presented by Dimas Triwibowo ST. Dimas was born in Bekasi 1992. He obtained Bachelor of Industrial Engineer from Universitas Gunadarma, and now is still pursuing his master degree in Forest Product Technology in IPB University. He is a researcher in Research Center for Biomaterials, BRIN, since 2018. He has published 6 articles and 2 industrial design since 2018. He focuses his research on product design from bio-based material. Mr. Dimas will present the research with the title Hot Pressing Treatment on Physical and Mechanical Properties of Comply Bonded with Citric Acid. It is written by Dimas Triwibowo, Narto Sudarmanto, Fazar Akbar, Yusuf Amin, Sukma Suryakusuma, Yusuf Sudohadi. Please play in the video, Mr. Handoyo. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. My name is Dimas Triwibowo from Research Center for Biomaterials, LIPI. I would like to present the result of a research entitled Heat Pressing Treatment of Physical and Mechanical Properties of Comply Bonded with Citric Acid. In this presentation, it will be divided into several sections such as introduction, research objective, materials and method, result and discussion, and conclusion. Bamboo is a non-timber forest product that has the potential to be used as an alternative material to replace wood. This is because bamboo in Indonesia has 157 types of bamboo. Bamboo also has a fast-growing period of 3 to 5 years. In addition, The amount of bamboo production is very abundant. In the years 2018, the total production of bamboo reached more than 20 million sticks. The use of bamboo by the community is generally used as handicraft, such as weaving, making tables, chairs, cabinets, and shelves. The use of bamboo as building material traditionally uses bamboo stems as support poles, roofs, window frames, and house walls. Along with the development of technology, the use of bamboo as a building material is no longer used as a wall. The development of bamboo-based building materials in recent years has been made into composite panels. Various composite panel products that utilize bamboo include oriented strand board, laminated bamboo wood, cross-laminated bamboo, and particle board. The manufacture of composite panels from bamboo generally uses synthetic adhesive such as urea formaldehyde (UF). This adhesive can be used for hot pressing with various types and amounts of catalyst. In addition, UF adhesives have good strength, are faster to set up, and are ineffective. However, as, as a synthetic adhesive has formaldehyde emission that can harm the environment as well as human health. The impact of formaldehyde emission can cause irritation, skin allergies, shortness of breath, and damage to lung function. Based on the harmful effect of formaldehyde emission produced by synthetic adhesive in the decade, more and more wood adhesive have been developed for natural resources that are safe for human health. One source of natural ingredients that can be used as a natural adhesive without the need for formaldehyde is citric acid. Citric acid is a weak acid that comes from lemons, oranges, tomatoes, and beets. Citric acid is used as a preservative, flavoring, and emulsifier in the food, beverage, pharmaceutical, and cosmetic industries. The previous use of citric acid in wood was only as a cross-linked and was able to increase the physical and mechanical strength of the wood. The first application of citric acid as a wood adhesive was carried out by Umemura et al. In 2011. The study showed that citric acid can bond well to the hydroxyl groups of wood. Therefore, citric acid has a large capacity as an environmentally friendly natural wood adhesive. The application of citric acid will be used in the manufacture of Comply. Comply is one of the new products of composite panels. Comply is a superior product because it can use low-quality woods, small diameter, even wood residue in the core layer and use thin layer veneer on the front and back layer. Therefore, the utilization of high-quality wood will be minimized, while the Comply appearance in the same as for plywood research on Comply is still not much down. In fact, the potential for Comply as an alternative product to replace composite is quite large. The objective of this research is knowing the effect of the manufacturing method on the characteristics of Comply made from betung bamboo particles and sengon veneer. Knowing the effect of hot pressing time on the characteristic of Comply made of betung bamboo particles and sengon veneer. Betung bamboo is used in air-dry condition with a moisture content of 12 to 15%. The bamboo stalks are cleaned and the chopped using a drum chopper. Next, the chopped bamboo is inserted into the ring flaker. After that, the bamboo particles were filtered to obtain a particle size of 14 mesh and 320 mesh, about 0.841 millimeter. The bamboo particles are often dried at 80 degrees Celsius to a moisture content of 4 to 6%. The veneer used has a density of 0.3 gram per centimeter cubic, with the dimension of 30 centimeter long, 30 centimeter wide, and 0.3 centimeter thick, and a veneer moisture content of 10 to 12%. Citric acid in powder form is mixed with water in a beaker glass to dissolve the citric acid. After that, it was put into another beaker containing water at a temperature of 70 degrees Celsius and stirred with a stirrer at a speed of 300 rpm for approximately 20 minutes. Furthermore, the beaker glass containing the citric acid solution was removed and allowed to stand before use. The solid concentration is 59%. The first step, often dried bamboo particles were sprayed with a solution of citric acid with a solid content of 59%. After that, the particles are dried in an oven with a temperature of 80 degrees Celsius so that the moisture content of the particles reaches 4 to 5%. Next, the particles are put into a 30 centimeter times 30 centimeter mold with a veneer at the bottom, which has been sprinkled with 150 grams of citric acid solution per square meter in a single spread, and on the top too. Finally, it is hot pressed at a temperature of 200 degrees Celsius with a compressor pressure of 10 megapascal. The target thickness of the comply is 1.3 centimeter. The manufacture of comply board is done by two methods. The first method is the manufacture board directly, namely by direct compression between sangon veneer which have been coated with citric acid adhesive on the bottom and topped with betung bamboo particles at the core. The second way of making is done by first making particle board from bamboo particles that are dried in an oven. After that, the particle board was coated with sangon veneer which had been sprinkled with citric acid solution on the bottom and top on the particle board. The variation of pressing time for each manufacturing method is 8 minutes and 10 minutes. For more details, please refer to the slide. Physical and mechanical properties testing was carried out with reference to Japanese industrial standard A5908-2003 for particle board. For the type of test and sample size can be seen in the table. Based on the result of physical properties testing, the method of manufacture is in stage with a hot pressing time of 10 minutes. This is based on the test value for moisture content, density, thickness swelling, and water absorption, which are still below the maximum limit of the standard value. This is presumably due to the influence of density and moisture content of the compound. The higher the density, the lower the water absorption and thickness swelling. Based on the result of the MOA and MOR test, the stepwise manufacturing method with a hot pressing time of 10 minutes has a higher MOR value than the others. Meanwhile, the stepwise manufacturing method with a hot pressing time of 8 minutes has a higher MOA value than the others. However, the MOR and MOA values are still below the minimum standard values. Based on the result of internal bonding test, the manufacture method in stepwise with a hot pressing time of 10 minutes has a higher value than the others. However, this value is still below the minimum standard value. The conclusion of this research is the stepwise manufacturing method with a hot pressing time of 10 minutes has better physical and mechanical properties than others. However, all the values obtained from the mechanical properties do not meet the standard value. This reference. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Mr. Dimas, and be ready for the discussion. We have two questions, please. One man, one question, please. Dozo. Yes, please, Mr. Adli. Short and one question.
Oh, okay. Thank you very much. Only one question. I will combine the question become one. Okay, thank you very much for the interesting presentation. Yes, the development of bio-based adhesives is really important and interesting. I have a question, one question. Please answer. Is citric acid classified as adhesive or cross-linker? Or cross-linker? If adhesive, what type of adhesive? Thermosetting or thermoplastic? Thank you very much.
Thank you for the question, Mr. Adli. I think citric acid thermosetting because citric acid because citric acid use temperature for its curing time.
So how do you know it is thermosetting? Because I already checked the citric acid gelation time. It's over than 30 minutes. It's not cured. It's not gel. It's still liquid. After 30 minutes, and then boil at 180 degrees Celsius.
I think before I hot press bamboo and vinyl in hot press, I dried bamboo after spray in oven to lose water. So only citric acid in particle bamboo is my answer.
I'm sorry, but can I try to answer?
Yes, please.
Yeah, I think Dr. Adi is right, because I think it should be need more higher temperature and more longer time to cure the citric acid. So that's why the MOE and MOR is still lower, because maybe the curing is not so perfect. Maybe, I don't know. Is it correct? I tried to use citric acid, but at that time I tried at about 50 minutes in 180, but just for to fix the compression wood, but not the particle board. I don't know. Yeah, should be. Thank
Yeah,
you.
I think it's citric. I don't know. Maybe Dr. Sukma is with us or not, but I think citric acid is not a 100% thermosetting, because when I check the gelation time, even 30 minutes at 180 degrees Celsius is still liquid. So it needs more time and conditioning to room temperature for curing. So if we boil again, it's only evaporate the water. But after we put in room temperature, it will become cured, become gel and solid, something like that. So it needs a combine. We need to combine the hot pressing and also cold pressing. I think something like that.
Okay, thank you very much, Dr. Adli. And then please, Dr. Widya, question, suggestion, comment.
Thank you, Dr. Imran. It's an interesting presentation, I think. I just want to future mind, maybe. In your conclusion, stated that the mechanical properties doesn't meet the standard. Is it right? Yes, I think you stated that in your conclusion. So what is your maybe future treatment to obtain the mechanical properties will be meet the standard? How do you think about this question?
Yes, thank you for your question, Bu Widya. The next project or the next result, I will to increase to density for the comply to reach the standard in this particle board. This must answer.
How much the target your density in your comply?
Maybe 0.6 or 0.7. Yeah.
0.6 until 0.7.
Yes.
No, in your current study, you get the density in which average? Your density of your comply in this research, how much?
In this research, my density in comply is 0.4.
0.4.
Until 0.45.
Okay.
Yeah, this is lower density, Bu Widya.
Okay, in the standard, maybe in for complaint that you use the standard, how much the density that required to obtain the mechanical properties or also maybe the physical properties?
Yes, in standard or in this
yes.
No, only to I'm sorry, I'm difficult to explain for English. Maybe I can explain to bahasa ya, supaya tidak ya. Jadi di standarnya itu tidak mengatur Bu beberapa kerapatannya ya. Dia tuh hanya di standar itu mengatur minimal itu 0,4 sampai yang paling besar itu 0,9. Dan di sana hanya mengatur minimal untuk kekuatan mekanisnya ya di 30 Newton per milimeter persegi. Seperti itu Bu.
Okay, thank you, Dimas. Maybe for
Yes,
the next you may use in English
Yeah, yeah.
because this is the even international conference.
Yes.
Maybe
I'm
for
sorry
Dr. Imran
Dr. Widya.
can
Yes.
be manage this session. Thank you.
Yes, thank you very much for the suggestion, Dr. Widya. And thank you very much for Mr. Dimas for the presentation and discussion. I also thank to all the audience that have big enthusiasm in the session. And we will continue after the lunch break at 13:30. And we thank you again for your enthusiasm and the question, comments, and suggestion. It is very important for the presenter and the presenter. And we also if you want to get a connection with the presenter, you can contact us or directly contact to our presenter, invited presenter or presenter, because they are very kind to do that. Okay, thank you very much, and then see you after break lunch at 1:30. Thank you very much.
Hello everyone, are we going ready? All the patients are ready. We have 4 presenters for the next chapter of this parallel session. We have Mr. Teguh. Hello, Mr. Teguh. We have Mr. Teguh. Can you hear my voice? We have 4 participants in the next chapter of this parallel session. We have Mr. Teguh, and then Ibu Riana, or maybe Mr. Jauhar can be replaced her. And then Ibu Listia Mustika Dewi. And the last but not least, we have Mr. Oktan Hayat. All the presenters ready? I can see Mr. Oktan, okay, Ibu Listia.
Ready, Mas Adi.
Okay. Mr. Teguh, hello. Mr. Teguh and Mr. Jauhar Habibi.
Yes.
Okay.
Yes.
Mr. Teguh, how about you? Where are you? Hello. Or we are going to the next presenter after Mr. Teguh, Mr. Jauhar maybe. Okay. Mr. Handoyo, can you hear my voice? Okay. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, now we are ready to next chapter of this parallel session. With my pleasure, I'm Bahanawan, College of Dr. Imron, who has already moderated you. And now we are going to next participant, number 7.6. I'm sorry, 7.6. 7.6. We have a presenter with the title Durability Characteristic of Australian Polaris Wood Treatment by with Kerbereman has ethanol extract at the end schizophyllum commune attack. That this presentation will deliver with from Mr. Jauhar Habibi. Okay, Mr. Jauhar Habibi has already joined with us.
Yeah.
And now, short on time, please, Mr. Handoyo, IT.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Thank you for coming. Let me introduce myself. My name is Jawar Kabibi. I will present my research result with the title Durability Characteristic of Alsonian Scholaris Wood treated with cerberamong acid ethanol extract against schizophyllum commune attacks. Here, research in collaborating with Mrs. Riana Anggreni, Mr. Albayudi, and Ms. Ria Elvia Reani. Indonesia is a mega biodiversity country with a bird of animal and plant, including three species such as Scholaris, which produce wood for furniture and handcraft. But it has a low quality, especially in durability against wood destroyer organism. According to the Standard National Indonesia, a Scholaris has 4 until 5 durability guides. So we need a preservation process to increase the wood quality. We can use synthetic chemical compounds such as insecticide, wax, boron, nanozinc, and GCA. But it has several weaknesses such as a high cost, high technology needed, and human resources, and also not an environmental friendly. So we need an alternative compound which is an environmental friendly. On the other side, we also have a Cerbera manghas, which is an adaptive tree species. This species is not fully utilized, such as fruit, seed, bark, and leaf. Cerbera manghas has an extractive that contains cerberin. It has several effects such as antibacterial, antifungal, and insecticide. So it is matching as an alternative for wood preserving. But we still need to investigate is that work effective for wood preserving. And the method we prepared 100 sample in size 1.5 times 2.5 times 5 centimeter for retention, absorption, weight loss, and stock bill. Extract we prepared from Cerbera using maceration with an comparison 1 to 3 in weight to weight. After that, we concentrate it using rotary vacuum evaporator, and then the concentrate extract was prepared for GC analysis and also for wood preservation. Wood preservation was done by soaking in 48 hours. After that, we drying in the open air. After that, we do evaluate for the preserved wood using schizophyllum commune and several analyses such as retention, absorption, and weight loss. The result shows that there are no difference in moisture content of Astonia scolaris wood, and also all the moisture content is under the standard, under 50%. We know that the ideal moisture content in Indonesia is around 18 to 12%. Higher than this will be inhibit the retention and absorption of extract. And the third, the lower moisture content makes the extract easier to enter the wood cell. For the retention result, we know that the concentration extract of cerberaceous acid is correlated with the retention value. The higher concentration extract will increase the retention value. From this graph, we know that the highest retention value is in the 18% of cerberaceous acid extract. The absorption results show that the concentration extract of cerberaceous acid is correlated with the absorption value. Similar with the retention value, the higher concentration extract will increase the absorption value. And also we can know that the highest absorption value is in the 18% of concentration of cerberaceous acid extract. For the weight loss, we can see that increasing the concentration inhibit the schizophilum commune attack. According to the SNE 01-7207-2016, we know that the concentration 40 to 60% and 80% can increase the Astonia scolaris wood durability into the class durable 3 and 1 respectively. This is the picture of the wood sample for the 0% of concentration extract until the 18% concentration extract. We can know from one that the different effect of schizophilum commune, we can see the physical phase of the surface of the wood, that the 80% is have lower damage than the 0%. And second, we know that the increase in the concentration inhibited the schizophilum commune. From the GC analysis, we get 35 chemical compounds, which is, we can resume that we have 5 dominant types of compound. The first is octadecan, nonadecan, henecosen, tetratetracontan, and tetracontan. Several of these 5 dominant types compound have the effect of antibacterial, antifungal, and insecticide. So I think this is affecting the cerberaceous acid extract ethanol to inhibit the attack from the wood destroyer microorganism. From this result, we can get 3 conclusions. The first, concentration of cerberaceous acid ethanol extract had a significant effect on the retention, absorption, weight loss of Astonia scolaris. The second, the giving of cerberaceous acid ethanol extract concentration both of 40 to 60% and 80% was able to increase the durability of Astonia scolaris. This concentration is increased the durable class into 3 and 1 respectively. Third, cerberaceous acid ethanol extract contains 35 types of compound. The 5 dominant types of compound are octadecan, nonadecan, henecosen, tetratetracontan, tetracontan. And this type of compound has the capability as an antibacterial, antifungal, and also the capability of insecticide. Thank you. I think this is enough for me. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Jauhar and the co-author for the presentation. Okay, we have about 5 minutes. Please raise your hand and turn on your camera to deliver your question. There is question, Mr. Oktan maybe? Prof. Wahyu, or the other participant, Ibu Dona, Prof. Iliati. Mr. Jauhar, what what species that I should do? I should call this main fair in Indonesia in the local.
Yes, Cerbera manghas, I think. Bintaro.
Oh, Bintaro, okay. It's Bintaro, okay. I think this Bintaro is very common plant, but let's develop maybe about the how the effect this in land of in technology of the antigen or antifungal. Okay. For interactive, I deliver you, all of you, to take a place and turn you on your camera to deliver your question. There is no. Okay, Mr. Jauhar, is that true that the main component of anti-fungi maybe or anti-termites maybe is phenol? Phenol.
Yes. I think phenol is one of that compound that can be used such as anti-fungi. Like we know that tea, water tea or drinking tea, it has several components such as phenol that also can be used such as an antifungal and also antibacterial. So I think phenol is one of these compound type that can be used for the antibacterial or antifungal treatment.
Okay, but in your current research, there is no data about phenol compound.
Yes, maybe because I'm not doing a characteristic on that kind of the phenol, so I cannot or we cannot yet find that there is a phenol compound in there. But I'm surely that there is a phenol compound in that extract, because we know that DCMS characteristic have several types that we cannot match if we do not have the data before, like that, I think.
Okay. We have Dr. Adli. Maybe you have any question, Dr. Adli? Please send your question, Dr. Adli. Maybe do you have any question? Hello? Okay, maybe there is no question again. Thank you very much, Mr. Jauhar Habibi, for your presentation. I hope it will become more interest discussion in this session. Thank you very much. Give applause to Mr. Jauhar and the co-author of this session.
Thank you.
Okay, thank you. And then we are going to next presentation. For next presentation, we have already has joined with us Mr. Teguh. Yes, Mr. Teguh is one. He started working on Research Center for Biomaterials, BRIN, since 2005, and now the focus of his research on the basic properties of wood properties enhanced through modification and engineering. Okay, to shorten time, please play the video.
Assalamualaikum warahmatullahi wabarakatuh. I am Teguh Darmawan. In this session, I will present our research title, Effect of Densification and Steam Treatment on the Quality of Laminated Bamboo. Bamboo is a potential raw material for various products because the availability of bamboo is quite abundant. Most non-timber forest products in Indonesia have short harvest time, about 3 until 5 years, and good mechanical properties. From these engineered bamboo products, laminated products are relatively more efficient in the use of adhesives. The types of adhesives commonly used for laminated bamboo with large size and thicknesses are adhesive types that can be set at room temperature or cold pressing processes. Lu et al. Reported epoxy is an adhesive can be used to produce laminated timber because they have good values for physical and mechanical properties, including delamination and shear strength. The manufacture of square section slat has several disadvantages, including a lot of discarding the cylindrical part of the bamboo. Square cutting will be effective only on bamboo species that have thick walls, and making a square slat will cut the part near the skin, which actually has the highest density. The shortcoming in the manufacture of bamboo can be reduced by the use of bamboo slat that still maintain the curvature of the bamboo. Bamboo slat with curved cross-section can increase the yield bamboo slat and can increase the strength of laminated bamboo. This was proven in the experiment by Mujiman et al., where laminated bamboo beam from curved slat have better mechanical properties than laminated beam from square slats. Laminated beam of curved slat are more resistant to loading, more rigid and ductile. The strength characteristic at each position of the bamboo stem have the same pattern as the density distribution, because the strength of the material is strongly influenced by its density. On the inner part, it has a low density and so soft so that it will become an area of weakness when laminated bamboo is made. One of the effort to increase the density can be done by densification, where the deformation start from the weakest part of the cell wall, so that softer part of the bamboo will compress first. Choose densification can regulate the uniformity of the density of bamboo slat from the bottom and middle of the stem as well as on the inner part. Based on this background, this research objective to optimization the amount of epoxy adhesive used in the manufacture of laminated bamboo from curved cross-sectional slats and homogenize the characteristic of laminated bamboo through the use of bamboo slats that have been compressed by steam treatment. Research method. The main material used are sembilang bamboo, Dendrocalamus giganteus Munro, and epoxy adhesives. Bamboo was obtained from the Research Center for Biomaterials LIPI Cibinong, and for adhesive, use Kibon epoxy adhesive produced by PT Kondisi Lemindo Indonesia. Bamboo sample preparations. The bamboo stem will cut at the bottom and upper part with a length based on an inner diameter with a set at least 60 millimeters. Then the number of segments was calculated and grouped into 3 parts at the bottom, middle, and upper part based on the thickness of the bamboo. The segment used was cut into a cylinder with a length of 50 millimeters, then split with a width of 50 millimeters, and clean the outer and inner part of the bamboo using wood surface sander. The first group was laminated bamboo without a compression process. The bamboo used in this study had an air-dry moisture content. Laminated bamboo is made with a target thickness of 5 centimeters, so the number of layers of laminated bamboo at the bottom, middle, and upper part were 4, 6, and 10 layers respectively. Adhesive consists of two components in the form of resin and hardener, 1 to 0.8. The adhesive is applied in a double spread with a glue spread of 100, 120, and 150 grams per square meter, and prepared on a mold. The mold was made with a curved shape on the upper and bottom surface, so that bamboo slat with a curved cross section can be compressed without failure. The compression was carried out for 24 hours at room temperature. The second group was laminated bamboo from compressed bamboo slat. Bamboo slat used in wet condition or saturated fiber point. The bamboo slat will arranged in a mold and compressed with a compression ratio of 50% for the bottom, 30% for the middle, and for the top is not compressed. Furthermore, the test sample in a mold was inserted into the chamber and steam treated at the temperature of 160 degrees Celsius for 60 minutes. After that, it was dried in an oven at a temperature of 100 degrees Celsius for 24 hours, and then glued with the total weight of the glue spread according to the best result in the previous process. Testing of physical and mechanical properties. Physical properties testing includes measurement of moisture content, density, and delamination. For testing the mechanical properties carried out is the shear strength test. The method of measuring moisture content, delamination test, and shear strength test refer to Japanese agricultural standards for glue laminated timber 1152. The shear strength testing of laminated bamboo using a Shimatsu universal testing machine. The adhesive line will observe using a digital microscope Canon VHX 6000 models, followed by measuring the thickness of the adhesive line using ImageG software. The research design in this study was a completely random factorial design, and each experiment was repeated 3 times. The data analyzed by variance at a 95% confidence interval if there was significant difference, followed by Duncan test. Result and discussion. The result of the measurement of moisture content, density, and delamination, and shear strength values are shown in the table and chart. Based on the analysis of the result of the immersion, boiling, and shear strength tests that have been carried out, it can be seen that the effect of 120 and 150 glue spread on the delamination value and shear strength was not different, so that 120 grams per square meters can be chosen as the optimal glue spread. The sample has a moisture content according to the JSPS standard, not more than 12%. The density of laminated bamboo that has been compressed from the position of the bamboo at the bottom, middle, and upper part has an average value that was almost uniform. The result of the immersion and boiling test showed that the adhesiveness of laminated bamboo was very good, where there was no delamination in all samples. The result of the shear strength test show that at the bottom there is an increase, shown that it is not much different from shear strength of the middle and upper part. All samples have a shear strength that meet the standard of more than 5.4 megapascal. The position factor has no significant effect on the density and shear strength of laminated bamboo. The density and shear strength values were not different between samples made from the bottom, middle, and upper. This shows that the compression of the bamboo slat at the bottom 50% and middle 30% be a success in making the laminated bamboo have uniform properties. Microscopic observation. The average glue line size between 31 until 91 micrometers. The difference in the glue spread can be seen in the effect on the thickness of the glue line that occurred, where the more of the glue spread produce a thicker glue line. Observation of the glue line at a higher magnification showed that the adhesive and the bamboo slat will fuse together on the surface of the bamboo slat, where there was a contrast between the adhesive and the bamboo slat. In laminated bamboo with compression, there was no adhesive that was able to penetrate into the cavity or other bamboo component, so that the bamboo gluing cord was more likely to be a surface bond without penetration of the adhesive into the pores on the bamboo slat. And from this research, it can be concluded that based on the analysis of the result of the immersion, boiling, and shear strength test, it was known that glue spread 120 grams per square meters can be chosen as the optimal glue spread. Densification of the bottom and middle curved bamboo slats by 50% and 30% and glued with glue spread 120 grams per square meters resulted in a uniform laminated bamboo. Density and shear strength value did not differ between samples made from the bottom, middle, and top. This is the reference used. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Very interesting presentation. I think this is about innovation in wood in engineered bamboo products. So I give you maybe about 5 minutes to deliver your question. Okay, Mr. Altan.
Okay, thank you very much. My question is, I want to know, based on your experience doing this physical method treatment to bamboo lamination, is there any effect to the maybe microorganism treat the bamboo lamination? Is it improve the preservation of bamboo with the microorganism attack? And then my second question, maybe is the species of bamboo is affect the method that you use, and what kind of bamboo species that you use in your experiment? Thank you very much.
Thank you. Get your question, Mr. Teguh.
Thank you. I don't treatment this bamboo with anti-bacteria or fungi. Mr. Okan?
Yeah, but maybe you have experience to test the bamboo with
durability,
your treatment. Yeah, with the fungi, maybe other.
No.
Oh, no. Okay.
Yeah. There is no, but the second question is, there is any differences between species and your treatment? Maybe you can choose 9 with X treatment, and you choosing another one with I treatment. Please.
Can I answer? Because
First,
I'm
yeah, okay. Yes.
Yeah. Okay.
Yeah. We choose 9 because the diameter is biggest than the other. By the biggest diameter, so we can make the width of laminated bamboo more wider. So after we compare of about 7 bamboo species, we decided that 9 is better raw material for laminated bamboo. And about your question on preservation, we haven't do that yet, but I think by treated steam treatment, so the sugar will separate. I mean, will separate from bamboo components. So because termite like sugar or patty, I think by steam treatment it will be yes, decrease, or probably it's more resist against termite, but I don't know.
Very interesting. Very interesting. But this is a new product, maybe. If there is any change to deliver this product, maybe you will make a patent, or maybe design product of this faculty, maybe. Hello.
Hello. Yeah.
Yes. Oh, there is. My question is, I think for me this is a new product, maybe. There is any change to you and your college team to make it deliver furthermore, maybe give it like change to be a patent or design product, maybe. I don't know.
Yes. Yes, ma'am. Please.
Yeah, we already proposed the patent. I think we now make a draft of patent, but we need the prototype to requirement for propose the patent. And try to connect each other because we separate the nodes. Is that so?
Okay,
yes.
Okay, so ladies and gentlemen, there is a new product from Research Center for Biomaterials that conducted by Mr. Tejo and the team. So it is maybe any change to deliver this product, maybe a little bit about the patent potentially or design product. So this is the end of this presentation. Give applause to Mr. Tejo, Prof. Wahyu, Mr. Oktan, and the others. Thank you very much. Okay, we are going to the next presenter. We have two more presenters. And the next, Ibu Listia Mustika Dewi has already joined with us. And okay, please, Mr. IT, Mr. Handoyo, play the video. Thank you.
Good day, everyone. I'm Listia Mustika Dewi from the Center for Standardization of Sustainable Forest Management Instruments, formerly known as Forest Product Research and Development Center, Indonesian Ministry of Environment and Forestry. Today, I'm going to present our study about anatomical and fiber quality characterization of the least known wood species of Icacinaceae, Cardiopteraceae, and Stemonuraceae. To begin with, we know that in Southeast Asia, the timber classification has been differentiated into three classes, such as major commercial timber, minor commercial timber, and lesser known wood species. In Indonesia, there are many wood species have not been studied, categorized, and commercialized. We categorize these groups as the least known wood species. Many less known wood species remain unstudied and can be potentially utilized as bioproducts. Data recorded from Silarium bogorian shows that there are more than 500 wood species that have not been studied. In this study, we selected wood species belong to the least known wood species from Icacinaceae, Cardiopteraceae, and Stemonuraceae. In Indonesia, we have Silarium bogorian that has been acknowledged as the largest wood collection in the world. Currently, we have more than 200,000 specimens from most regions in Indonesia. The wood collection and database from Silarium bogorian have been used as reference for wood identification process and also support research development. As an accredited laboratory for wood identification in Indonesia, we recorded wood species from various customers during the last decade, and it is shown that people nowadays are not only use commercial timber, but also have already selected the least known wood species. Therefore, studying the least known wood species become increasingly important. In this study, we were focusing on determining anatomical structure of the least known wood species belongs to three families. An assessment on fiber quality was also undertaken to determine the quality of selected wood for pulp and paper raw material. This table shows the detailed wood species used in this study, including local name, origin, and specific gravity from our database. For anatomical characterization, all wood samples were cut into small blocks and softened using glycerol, then sliced in 20 to 30 micron using sliding microtome for transfer, radial, and tangential sections, then stained with severanin and mounted with entelan. The anatomical observation following the standard by International Association of Wood Anatomists. Fiber maceration was undertaken to measure fiber dimension and determine fiber quality for pulp and paper. Matchstick size samples were boiled in 60 centigrade using glacial acetic acid and hydrogen peroxide until bleached and soft. After the fibers were stained using safranin and washed until acid-free, the fibers were ready for measurement under light microscope. Anatomical structure observation and cell dimension measurement were carried out by using YES axio-imager microscope. The fiber quality of all wood species were determined by determining derivative value of fiber dimension. The criteria consists of fiber length, Frankel ratio, felting power, mole step ratio, flexibility ratio, and coefficient of rigidity. Generally, all wood samples were not significantly different in terms of wood color, texture, and grain orientation. The wood color ranged from yellow to brown. All the samples have straight to interlock grain except for citronella, which has wavy grain as shown in figure E. From all the observed samples, no unique pattern was actually identified except for Gompandra species in figure H, which has a darker pattern on the rice cells. All wood samples tend to be slightly lustered. Citronella, Gonocarium, and Uranda wood samples tended to be harder than all observed wood samples. The results show that the anatomical characteristic of all observed species can be differentiated from their cell types such as race, parenchyma, vessel, and fiber, both quantitatively and qualitatively. Apodites from family Icacinaceae can be clearly identified from the axial parenchyma types such as diffuse, diffuse in aggregate, and scanty paratracheal, and the thick-walled fiber cells. The main characteristic of Citronella species are the rays with distinct size, axial parenchyma diffuse, diffuse in aggregate, and scanty paratracheal. Larger rays commonly 4 to 10 seria, rays height more than 1 millimeter, and the presence of prismatic crystal in precumbent rice cells. These two Citronella species have similar main characteristic. The wider rays is clearly seen from all the sections. These two Citronella species also have similar main characteristics. From all 6 observed specimens of Citronella species show almost similar characteristics, except for the sample ID, which has thin wall fiber, while the others have very thick wall fibers. Interestingly, 4 specimens of Gonocarium species showed different features that can be clearly seen transversely. These 2 Gonocarium look very different. It can be differentiated from the vessel frequency, ray width, and axial parenchyma. The differences indicate that this specimen might be categorized as different species under Gonocarium genera. However, this 2 Gonocarium has very identical characteristics compared to the previous slides. In family Stemonoraceae, Gompandra species has key specific characteristics such as axial parenchyma diffuse in aggregate, narrow band lines up to 3 cell wide, and very thick wall fiber, very wide rays, and the ray height also more than 1 millimeter. And we can see the rays in 2 distinct sizes, and also the presence of the crystal sands. Transversely, Medusanthera papuana looks very similar to Gompandra from the previous one, but in radial section we can find the differences, especially in crystal types. For Uranda species, the diagnostic features are axial parenchyma diffuse, the uniseriate rays which can be observed in tangential surface, and all ray cells square in radial section. This table shows the result of fiber quality measurement for the 14 wood samples. The results show that the fiber quality of all wood samples belong to class 3 with a value of less than 225. Apodites species and Uranda species had the lowest fiber quality values compared to the other 5 observed genera, as they had the shortest fiber length values, while Gompandra and Medusanthera had the highest quality value among the 14 samples observed, with a value of 200 because the fiber length values of both species were highest among 14 samples. Fiber length has been considered to determine paper quality because it affects the physical properties of paper, such as strength and stiffness. So longer wood fibers will produce paper sheets that have better strength properties because they have a wider bonding area during milling and better stress transfer properties. In conclusion, the anatomical properties of selected species can be used for key identification database. All wood samples could be microscopically differentiated from their anatomical characteristics, especially from the type of rays, parenchyma, vessel, fiber, and mineral inclusion. Fiber quality for all species belong to class 3. However, the priority for pulp and paper production can be given to wood species with a total highest scoring, namely Gompandra species and Medusanthera species, while for the other species, can be considered for other purposes. I just would like to thank Silarium Bogorian Center for Standardization of Sustainable Forest Management Instrument for providing wood samples and laboratory facilities, and special thanks to technicians in the Lignocellulose Anatomy Laboratory for their support during the research. The authors are gratefully acknowledge the support from JSPS and JSTIP for providing funding to attend this conference and publication. This is the reference on this paper, and that's all my presentation. Thank you very much for your kind attention.
Thank you very much, Ibu Listia. Mrs. Listia, she started working as a researcher focusing on wood anatomy and wood quality in Center for Standardization of Sustainable Forest Management Instrument, formerly known as Forestry Research and Development Center for the Indonesian Ministry of Environment and Forestry (NOI) since 2011, and she is co-invention icon, right, Mrs. Ratu. So thank you for the presentation. We have about 5 minutes to question and answer. There is any question? Hello, everyone. There is any question? Maybe. Okay, Mr. Oktan. Please, your time.
Thank you very much. Maybe I want to know for your anatomical method for identification properties of wood, is it possible to identification to a level species of tree or not? Because in your research you only identification to genus level. Thank you.
Yep. Thank you very much for the question, Mr. Oktan. So actually it's possible, but generally we can be identify which species. I mean, in the genus level generally, but some species we can identify using anatomical characteristic in species level. For example, like for example, Tectona grandis, we only have one species, or we also try to identify, like for example, CITES listed species, that for example for Dalbergia species, that we tried also to identify the differences between the species to help to identify with species in the field to cross-check the correctness of the wood species. So we identified that there are some difference in the species level. So it depends on the species. So we still have work to do to complete all the database. So if in this group we have like from the universities, we strongly encourage that if any students who are interested in wood anatomy, we are very welcome to work with every researchers in Indonesia to complete all this database. Yeah. Am I answer your question?
Yeah. Thank you.
Okay, thank you. There is any question? Mrs. Listia, about your current research, how about the other parameters, maybe microfiber angle or degree of crystallinity affect the flow quality?
Yeah, that's the ultra microscopic level characteristic also consider in our research. That is, that is important to determine the quality. For example, for microfiber angle, we can predict it's really correlated with the stiffness and mechanical properties. So it should be included as well in the with basic properties research in wood basic properties, especially in anatomical characteristic, because by just measuring microfiber angle in using maceration, measuring it, we can predict the quality of the wood species, and also we can measure if we can get the data from piece to bark, we can also measure the juvenile from the transition from juvenile to mature wood. So it's very important for predicting the appropriate utilization.
Okay, determining quality. I get it. Thank you. This is very interesting. Any other question? 1 minute. There is no question. Okay, thank you very much. Thank you, Mrs. Lysia. Give applause
You're
for
welcome.
her. Thank you very much for your presentation. Okay, before we are going to next presentation, may I remind you later to fill the link presentation, and we will get all of your maybe your data about the email, your affiliation. So, and in the next time, in the next future, we can make a collaboration maybe. Thank you very much. Okay. Last but not least, we are going to the next presentation. Mr. Oktan Hudayat, he has already joined us today in this session. Vistas joined in Research Center for Biomaterials, National Research and Innovation Agency BIM, as researcher from 2019, and he focused on his research on the perspective of indigenous fungi in Indonesia as a green fungi. So the time, please play the video. Thank you.
Hello everyone, my name is Oktan Dwi Nurhayat from Research Centers for Biomaterials. And today, I'm going to talk about our research, the colorization study of acid blue 25 using immobilized Trimetacistuta ADN 082 inlike expanded clay aggregate. Well, let me start by giving you some background about our research. Today, providing clean water become quite challenging for us as mankind. The increasing activities in industry and agriculture generate a pollutant containing dyes, heavy metals, insecticides, and pesticides. One of the largest contributions to water pollution is wastewater from textile industry activities that consist of synthetic dyes. In addition, synthetic dyes and their secondary compounds have many toxic for aquatic organisms and human health. And all these kinds of wastewater have impact on reducing availability to clean water. Synthetic dye consists of many groups, such as anthraquinone, azo, and etc., and it's distinct based on their chemical structure. Acid blue 25 is wide application and distributed in market. However, it is also considered as a toxic compound that may cause a problem in the respiratory system organ and irritates the skin and eyes. Therefore, efficient method and strategy should be devised to remove such compound for wastewater. In recent studies, several methods are developed to remove synthetic dyes, such as physics and chemical methods. However, this method has limitations due to requires high energy, costly, time-consuming, and produce a large amount of sludge. So, many researchers prefer using biological method because it's cost-efficient and environmentally friendly. And it's using white rot fungi because it's produce extracellular enzyme like lignolytic enzyme, and it can remove synthetic dye via oxidizing mechanism. However, the application of white rot fungi using biomass has a drawbacks, so it needs to develop alternative techniques, such as immobilization, to prevent from environmental stress. The attempt of immobilized white rot fungi on various metrics has been successfully reported by some researchers. However, there are still few studies that conducted immobilization of white rot fungi in LACA. LACA has advantage characteristics for fungal immobilization, such as porous, like non-toxic, inert, resistant to high temperature, insoluble in water, and non-degradable. Moreover, the recent studies have demonstrated the immobilization process for fungal cell and lacase enzyme for RBBR, RB4, and AB129 removal. But there was no report about the application of the immobilized fungal cell Trimethylcerasuta on LACA to AB25 decolorization. So, the purpose of the study is to immobilize Trimethylcerasuta Aden 082 in LACA to decolorize AB25 dye and have investigated the characteristics of LACA after immobilization and the characteristics of all treatment LACA Aden 082 after decolorization process and the comparison activity of lacase enzyme between free and immobilized micellia Trimethylcerasuta Aden 082. This is the material and equipment during the study. An experiment was conducted at Integrated Laboratory or ILAB, Britain. Before the immobilization process, the inoculum was produced. The isolate was pre-cultured on MEA for 7 days and inoculated to MGP broth. While for LACA, the LACA was activated by steaming process, rinse, and dry. Next, for the fungal immobilization process, we following of Ardiati et al. Methods, and the morphology of immobilized fungus in LACA or myco-LACA and LACA was observed. Acid blue 25 decolorization assay was conducted using 3 treatments: LACA treatments, free cell, and myco-LACA. All filtered after treatment were monitored the percentage decolorization and the lacase activity during all contact time. Next, in result and discussion. In the result, we observed the different morphology between LACA or without fungi and the LACA with the fungal immobilization. In the surface morphology, in LACA with the fungi, as the control, the color was light brown and raw texture with pores was observed. In contrast, on myco-LACA, the white micellia were observed. On the other hand, the pores texture with black color were observed in the inside of control LACA, while in the myco-LACA, the white micellia were grew and colonized the LACA pores. We assume fungal cells were absorbed to the LACA by a physical adsorption mechanism and followed by cell adhesion and colonization. Next, for the decolorization assay, overall the chart shows us the immobilized Trimethylcerasuta gives a higher percentage of dyes decolorization than the 2 other treatments in its interval time of assay. The result indicates the immobilized Trimethylcerasuta Aden 082 efficiently decolors the AB25 dyes within 1 day. These results were in line with a recent studies experiment which was immobilized Trimethylcerasuta D7 in LACA that could increase intraquinine dye decolorization. In this experiment, we have proved immobilization of Trametes hirsuta can enhance dye removal through biosorption and biodegradation besides absorption mechanism via LECA material. To confirm that process, the comparison of change that occur between the immobilized Trametes hirsuta, free cell, and LECA treatment is observed. The observation result of the free cell after 24 hours under the microscope saw the HIFA color become blue, while the mycelia observed on the LECA surface become dark blue color. The color change in HIFA proves the primary decolorization process through biosorption in the first 24 hours. However, after 96 hours of treatment, the blue color is decreased from HIFA at free cell treatment as well as in Trametes hirsuta immobilized in LECA. This indicates the decrease of color intensity is caused by increasing enzyme production or concentration of fungal cell mass. The degradation of dye occurs both by enzymatic degradation and absorption to the cell mass. The observation of surface change of control LECA or without the fungi saw the difference in intensity of dyes that were absorbed was affected by increasing the contact time. In the first 24 hours on the surface of activated LECA, the blue dye particle is observed and the amount of blue particle dye is increased at 96 hours of treatment. The blue color observed on the LECA means AB25 dye decolorization mechanism by LECA can occur through absorption and no enzymatic process involved. The next results. The LAPAS activities were tested to monitor the association of enzyme activity to red decolorization, which is secreted extracellularly by fungus in free cell and myco-LECA treatments, and based on the result, the activity of LAPAS enzyme involved in the dye removal. In this case, AB25 dye acts as an enzyme substrate that can directly oxidize by LAPAS was utilized as a carbon source by this fungus. We also can see the immobilization of Trametes hirsuta in LECA clearly increased the production of LAPAS enzyme compared to free cell treatment. These results were in line with a previous study that demonstrated immobilized Peniopora cinerea on synthetic fiber can increase 35-fold in LAPAS enzyme production when compared to the free cell. In conclusion, let me sum up the main points starting with fungal mycelia of Trametes hirsuta Eden 082 was successfully immobilized in LECA. The immobilized Trametes hirsuta enhanced the effectiveness of AB25 dye removal when compared to the free cell and control LECA assay. Moreover, the fungal immobilized technique in LECA increased the production of LAPAS enzyme as well as improved the colorization of AB25 dye via biodegradation mechanism. And finally, thank you.
Thank you very much for interesting presentation. Now we are going to question and answer session. Please raise your hand. Okay. This is Ibutu. Please turn on your camera.
Thank you for the chairman. May I ask question for Mr. Oktan?
Where are you come from?
I'm student at Kyoto University now.
Kyoto, in Japan.
Yeah.
Live from Japan, yeah. Thank you very much for joining us.
Hi. Hello, Mr. Oktan. It's very nice talk and nice presentation. Thank you for sharing with us. It's my first time to hear about LECA, so I would like, how to say, give some asking question for you. from the treatment of your study, when you using 3 treatment, including LECA itself as a control, and it show us a little bit degraded color. So what is inside of LECA? I mean, is there any active compound there? So, and the combination of LECA and Trametes micellia is really amazing. It's a good result, and it's also like a very potential product to be like commercialized. But the problem is that you say this Mycoleca only have the activity around 4 days, and the Lacasse activity is going down after 4 days. So it's kind of a problem, but how was your opinion to improve this problem? I mean, can you more extend the period of the Mycoleca, so it in the industry, in the future, in the industry, you don't have to change very frequently of Mycoleca. So how was your opinion? This is my question. Thank you.
Okay, thank you very much for KGG. How are you? I hope you.
I'm good.
I hope you still good in there. Actually, about LECA is, maybe in Indonesia, is used for plant media because it's made from clay, basically clay. Do you know clay? Nah. And your second question, why the color of acid blue is in LECA treatment is little bit decreased, because we assume the color of LECA is decreased because it adsorbed to the LECA, but I think from the journal we have been reviewed, I think in the LECA there is no active compound that cause decreasing of color that synthetic blue. So it's purely about the absorption mechanism, and the changing color for the synthetic dyes with the Mycoleca. So maybe we assume this because the degradation from Lacasse enzyme. So the chromophore of the synthetic dyes is oxidized and it will degrade. So the color is decreased. And for the optimization, because the Lacasse activity is going down at the 96 hours of treatment, actually we assume it's normal because the synthetic dyes as a substrate for the enzyme is decreased, so the enzyme is not active again for decreasing of the synthetic dyes. I hope that's answer your question.
Can I put a comment? So when the Mycoleca already, how to say, maximum state, that they're able to degrade the color, so they will not more, they don't have any highest activity again after that. So we need to change the Mycoleca, something like that.
Okay.
Or like rechange the Mycoleca to the new mycelium of Trametes is better.
I think in this case, maybe Dr. Dede Herianto can help.
Yes, Dr. As the actual author.
Okay, Mr. Chairman, please, I would like to comment with Bu and Mbak Niputu ya, Mbak Gege question. So actually, if you see the result from the octans paper, it can be seen that the degradation of dyes after 4 days is already maximums. Then the concentration of dyes decrease. Then it's resulting the decreasing of the activity of Lacasse from the fungi. It means that the fungi already finished for degraded the dyes. According to our new results, we have already tried this mycoleca until almost 16 times by using the wastewater. Every 4 days we change the wastewater with the same mycoleca, and the very surprising result that the activity of the fungi or the colorization of the mycoleca, the colorization of the dyes by the mycoleca is still almost 100%. So we hope that this mycoleca will can be used for this wastewater treatment without any changing the mycoleca during the maybe 1 year or 2 years. That's all.
Well,
maybe we hope
some new information. Maybe that's
Yeah.
what is new. Good.
This is our
Thank you.
result.
Okay, Mr. Dede, has LICA been previously reported for the absorption of pollutants such as dyes or the other pollutants? Maybe?
Pardon, Mas Adik?
Hello? Yeah? Not just for dyes, maybe for the other pollutants.
Oh, yeah. Actually, we are doing for other wastewater, like from batik wastewater and maybe for polyaromatic hydrocarbon. We are still doing.
Okay, good. Good job and good result made. Okay, there's any question? One question. There's no question? Okay. This is the conclusion of this Mr. Okan and Mr. Dede presentation. And if you enjoy your research, doing something new and doing something that can show us in these sessions. And now, thank you very much for your presentation, Mr. Okan and co-author Mr. Dede, and the question from Ms. Niputu Krisanti from Japan, from Japan. Thank you very much for joining us today. And give applause for the presenter. Thank you very much. And now, Mr. Okan, as the final presenter of this panel session today, but we have another session. We will hold and looking for video of our head office to make closing remarks to us. But don't go anywhere. Don't go anywhere because I have several mentioning that you will have. Mr. IT, can you please play the video?
Excellencies, ladies and gentlemen, we have reached the end of the first international conference of Lignocellulose, Icon-Lig, in conjunction with the 10th International Symposium for Sustainable Humanosphere, ISSH 2021, that organized together by JSPS Alumni Association of Indonesia and Research Center for Biomaterials. By having this conference, we have to keep in mind this is a very special opportunity for us to go together, keep motivating with innovation and idea dealing with lignocellulose and humanosphere science. I would like to thank to all keynote speakers, invited speakers, and participants who have done outstanding sharing with us. Your sharing, your insight, and your experiences in this 2 days conference are a valuable knowledge for us. I would like to thank the JSPS Bank Office and JSPS Alumni Association of Indonesia for their great contribution and financial support. I also would like to thank the support from RISH-Kyoto University, Japan, and other participated institutions such as National Institute of Aeronautic and Space, IPB University, Universitas Islam Indonesia, Universitas Jambi, Universitas Lambung Mangkurat, Universitas Mulamarwan, Universitas Padjajaran, Universitas Trisakti, and others. Last but not least, I greatly appreciate to all those who have been involved in the organization of the event. Last, we look forward to seeing you again in the next year event. Thank you.
Thank you very much for step down for the closing remarks. Okay, ladies and gentlemen, before I close the session, please enjoy this video that the organizing committee prepared for me. Thank you. I will please play the video. Thank you very much. Before I closing, I want to give my honorable mention to all the the participants. I can see Dr. Widianto, thank you very much. Ibu Miss Professor Ignacia Maria Sulastisi, thank you for joining us. Mr. Dede Herianto, Ibu Ratih Damayanti, and the other one, I can spell, I can, all of you, So, okay, now it's time for me to close our session and happily and the first international conference of Lignocellulose that is held in conjunction with the 10th International Symposium of Sustainable Humanosphere. I thank you very much for an interactive session in such a joyful environment. We understand that some of you may require the for your professional interests. Therefore, we will update the program book especially for the outcomes, title, and abstract section following the final version of your paper that will be published in our Scopus Index proceeding. We will send the program book by your registered email. Therefore, please kindly check it especially at the beginning of October 2021. As for the certificate, we will complete then send it to your registered email before the end of September 2021. Okay, thank you for your participation. We are so grateful to share and to enjoy this moment with you. Have a great rest of your day. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Thank you. See you next year.
We can still join in the room 2.